all my titles in. That thing has gone red. Hey, cool. That thing still works after sitting for a couple days. Lights. Boom. Lights button hit. Lights confirmed. All right. This one, that's going to make it unwieldy. I need to point that camera at something relevant. Currently, it's dead weight. That procedure. Get our nice tones. Whoa, 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 whoa. Frame rate issue. Try hit the button again. See if that does it. I don't think the OBS stuff is accepting frame rate changes. That's a little better. Yeah, that's a little better. I think that's okay. So then we do this one. We'll get our focus level and our color temperatures all set. There we go. Frame rate's good. Frame rate's good. Okay. How are we doing today? Man. Oh, we got to turn the scope on. Scope's a little dusty though. I'm gonna dust it off first. Another project that we need to do soon. I don't know if we'll do it Friday. Maybe is put a 120 millimeter fan on the back of this thing because I don't really trust. We put a lot of effort into finding a quiet fan that was the right size to go inside of that little scope, but I'm afraid it's gonna damage itself with all the excess of heat. It's like 10 degrees warmer with that new fan in there. Oh, I need to make sure that all my chats are popped out. Let us do a testes here. Oh, thank you. Herr Bothan has tested that for me. We need to pop out YouTube. These are all the things that I need to remember before a stream. I need to make a list. I really do need to make just like a little checklist of stuff and put it on a whiteboard. You can automate a lot of these things though. Let's open that up. We're doing audio-ish today, and I'm back after like a million years. Oh, I need to make thumbnails still. Where's my sticky note? Where's my sticky note with stuff on it? Where's my sticky note? Where did you go? I don't know where they are. I did prescriptions today. I got that off of my checklist. Well, also off of my chest. Yes, that's also relevant. One sec. I'll be back at the desk in just a sec. I'm looking for my big blue sticky note. I don't know what happened to it. It's gone. It's gone. It left this mortal coil. Huh. I need to make like 10 thumbnails, and then I can expand on those in GIMP. All right, we'll try to remember that at the end of the stream, because that's something that I can do in the off time when I'm not playing Abiotic Factor. Playing too much of that game. It's way too fun. I need to get some IRL stuff done. I've been avoiding working the past couple days just because it's been burny-outy. I've been burning out. So we can top off this mixer and get that done, and we can get to some other little things that may need doing around here. And the eventual goal is getting back to burn the subs, which I thought the Node-RED stuff would be just fine, but it's not. I can't seem to get it to work. All the Node-RED-ish. And since the Node-RED stuff involves lots and lots of secret keys, I can't bring you guys along with the journey with me. I can't bring you along just because all of those secret keys will dox my whole stream. Somebody will be able to make a bot that'll go in and extract my stream key practically. It's pretty intense. It's a lot of permissions that you have to give the bot in order to run all of those different things. Be right back, making bot. You'd need to have it log in as me, and then it would me and my channel, and that involves some certificates and stuff getting passed back and forth. But if you get that key, if I did stream getting the Node-RED stuff to work, it would be possible that somebody who is poised and ready to strike would accidentally get that key from like one frame of video, and they could use it to exploit a lot of different things. They could defame me and get me canceled. I don't know if I'm popular enough for that, but still, the possibility exists. Sorry, I see dust, and I'm trying to get dust. There's dust all over the place. Everything's dusty. It's like I'm an ancient old man in a shop full of scrolls and dust. Oh, that's a very oldie problem that you're looking at there. This is more OTT music. I love OTT. Don't know what he's doing these days. Hopefully making it. but makes a lot of cool music. This is a 2024 album, so I guess they are still around. Monsieur Potsford. Potsford? Simon Potsford? Those are clean now. Those have been sitting for years and collecting dust. I gotta get my life together, chat. I gotta do all of the health appointments that I've neglected. Which I can practically do. I actually filled one thing that I did do. Let's see if I can get it out here without freezing the camera. I filled one of the crates here completely with the awe emotes. That is completely full of them, and I still have more in the bin. We might make, that's the wrong focus, hold on. I might have to make like an emote launcher. I don't know, this is too many emotes. That goes all the way to the bottom of the bin. I do not know what I'm gonna do with all this. I don't know what there is to do with all this. It's a lot. What up, Rex? How you doing? I'm back. It's been a bit of a little bit of not really a vacation. I just haven't streamed. I just couldn't do it. Hey, oh bother, how's it going? I think I was sick with something. I think I was actually kind of sick with something. Yeah, things weren't working right. Amazon fulfillment services. What does that mean? There's a lot of these. I got a lot of these emotes from Wexo. Learning Pro Tools. That's something I need to learn. Right now, we're going to be jumping into the frequency domain. We're not going to need that third channel. Don't think. We're going to have to make noise, and pump it into our mixer. And then I'm going to have to take a fast Fourier transform of the output and take a look and see what they are. I don't think people will pay $15. Sell them for $50 each. Amazon handles packaging and shipping for you. So I just send it over to them and they take a little cut off the top. You know what Pro Tools is? Yeah, I know a lot of things about a lot of things. Yeah. Have I used Pro Tools? I think I thought about installing it at some point when I was having audio routing issues and stuff. It's just another workstation, right? Or is there more to it? Why is this stuck up here? Yeah. What version do you have? No, I don't. I do not. I don't have a version because I don't have it. I just know of Pro Tools. Usually when you do like an art installation that has something to do with music, they're using Ableton, but I know of Pro Tools. We should get this front panel of this thing started, although I'm not doing this stream is not a hashtag AutoCAD ad, so maybe I'll wait until afterwards and do that. I need to do print out at least one panel for this thing so that I can put it up here. And then I need to make thumbnails. Ableton is the Dom Perignon thing. Huh? I don't understand. I don't know what that means. I don't know what that means. The Dom Perignon of digital audio workstations. Oh, it's sort of like the Apple type where it like looks like it doesn't really do anything, but when you get in there, there's like a lot of deep layers to it, and it pretty much does everything very cleanly. It does everything very cleanly with a very easy to digest interface, which is, you know, that's what I like about Apple stuff. I'm not a huge Apple fan. I'm not one of the fanboys. I don't overly justify all of Apple's stuff. But what is it? AutoCAD, my Fusion 360 works like that, and I appreciate it. Cubase for life. Good in terms of EDM stuff. What we used it for a lot was to just set off relays. We did that multiple different ways. You can do it with piano rolls. You can make custom plug-in tools for that kind of stuff. I know the guy who does the something-atron that kind of orchestra where you have a bunch of disparate like bells and stuff, like different ways of ringing bells and making soothing noise. Gamelatron, there we go. The guy who does Gamelatron uses Ableton Live. Yeah, for that kind of stuff. He uses a lot of solenoids that set off stuff. I have not looked at MainStage. I don't know what that's all about. I was going to try to use Ableton to try to get my audio stuff into like one thing. I figure I should probably at this point make some physical kind of EQ stuff, because I don't get the right EQ from these programs. They give you not quite enough control over the EQ. Reason for sound design and Cubase for composing, which works well enough. Interesting. I don't know anything about these tools really beyond my own superficial understanding and search into them as doing things for Streamer Man. Veet Nukem subscribed with a Prime. For 38 months, Veet Nukem, I never used an Apple product in my life. That's interesting. We grew up with Macs, so I had all the early like LC3 type Macs, and then I switched over. I got an E-Machine. Whoa! That could play Descent too. Whoa! But yeah, from there it was Windows. Just because I could fool around and like mess things up in the Windows machines more than with the Apple products. Although I did mess stuff up in the Apple products. I did some hex editing for AOL, and in the AOL program, you could find the instant message like text color, and so I would hex edit the text color and be able to use unique text colors in my AIM. And then Wares came along, and all those script kids learned how to do that stuff to the nth degree, where they had a color changing text and stuff. And that was all apparently supported by the format of whatever the hell chat was doing, which was, it was a long time ago. But it was funny because I'm like, I can use any color. Quits program, opens hex editor, looks for the specific part of the hex that represents the color, look up the key of colors per hex, type it in, save it, close it, open it up again, go back to the conversation. See? Question mark? Enter. It's horrible. Touch OSC Pilot. Never used an Apple product. Okay, got that one. PC is way better for other stuff. Mac's good for reliability. Pro Tools and DaVinci Resolve. If they don't give you the options to mess everything up, then your setup ends up being the same every time you open it up. I have troubles with that for Stream. For Stream, things happen, and things get configured weird and wrong. The Windows machine does certainly let me get into all of the nooks and crannies of the settings and the configurations, but if I didn't have that kind of control, would I be having the same problems? That's sort of the design philosophy schism between PC and Mac. With Mac, you can get to that stuff, but it is an absolute nightmare to get down to that sort of level. At least in my experience of using it. And then Linux is, I must be in control of all things, and I will suffer for this, and then tell everybody else to use Linux. FL Studio gives me pain, I suppose. Fruity Loops was like the name, though. That's what everybody learned how to use. Why is there a drug bag over here? Oh, it's got miniature washers in it. Those need to find a home. Right. All right. It's not going to take much for today to get everything done. The other stuff that I really wanted to do, and I don't know if I want to bring you guys along the ride with me on that one, because it really is kind of just like base level work. It's not like exciting engineering stuff. I have trouble with making the show actually exciting. The base level stuff that I need to do are the tweaks to the board, and boy would it be funny if Julian came along and he said, I love it, it works perfectly, except I would rather have everything upside down. In which case, this board now works again just fine, only the arrows on the knobs are pointed downwards. Right now, as I have it configured, this one has a bodge wire fix that makes it so the knobs go the right direction and the little notches face upwards in the middle. The thing that I would bring you guys along with on the journey is all the tweaks that I have to do with this board. It involves a lot, because when you change 3 of the major elements' polarity, you flip those you flip the positive and negative connection. the trace routing is going to become an absolute freaking nightmare. It's going to be very, very difficult to rerun all those traces. I'm going to have to rip up a lot of stuff, reroute a lot of stuff. I'm going to have to work 3 steps ahead of myself a lot of the time, because if you move one thing, you're going to have to move another, you're going to have to move another, so you got to rip up all that, move this thing that way, optimize that, then this has to go a certain way because this is going to come in here, and then finally you get all the way back. This is why, and again, you guys have seen it in my intros and the way that I explain things to you guys, I am capable of going off on about 6 or 7 tangents and then wrapping them all up as I go. I don't often succeed with that, but when I do, you know, at least Julian commented on it. He's like, I can't believe you got all the way back to the subjects you were talking about. That's how I work, and that sort of plays into routing traces on a circuit board. If you're not using the auto router, which you can use, and then it does all that mental work for you. But apparently, one of the fundamental ways I'm wired is that I can, you know, scoop up all those extra projects and then come on all the way back to what I was working on originally. I don't know if it's something to brag about, but it certainly helps with the PCBs, because one thing can affect a lot of little things. As a streamer, you got to be good at tooting your own horn. So part of the 2-layer challenge of this board was, again, tooting my own horn and saying, look what I did in 2 layers with only 10 millimeters. Could barely even fit the chips on this thing. JLC PCB luckily has the resolution that allows me to do this. I would like to include in the next version of the board a little tiny notch where the legs of the pots go. Even though that won't bust them in, it could get me to not overrun the width, because I think right now as it is, we are above the 2 HP, 2 horizontal positions that we are allotted. It's like 10.5 or something like that. Less than that, I think. Yeah, and we're at 10.8. It's like they're going to have to move a little bit. How thick is this stuff? This sounds cool. It can't be 1 millimeter wide. Hold on, let me get a better measurement. Yeah, this stuff's cool. It's a 0.5 millimeter wide. So if I take 1/4 millimeter off of the edges, I'm in kind of that gray space where I could say, oh, so sorry, didn't know that I was too big to be in eurorack. I don't know, it's tough, because if I take in the full distance and I actually get it to fit within 10 point something millimeters, the problem is that I have to take huge notches out of the sides, and then my traces might not actually be able to be run the way they are. And so that's major ripping up, it's major issues. I should have done all the mechanical and said, there, that's your canvas. You can't alter that at all. But I did, oh, maybe I'll just forget to do the legs of the pots and we'll get back to that. Well, now here we are at that and everything is wrong. So, oh boy. I love me a good synth refrain. Actually, I really like me a good bass line, but I can't really hear the bass right now. I believe it is there because this fella knows how to make music. So, yeah, I guess I got my work cut out for me. I really need to make those thumbnails because those are going to be kind of vital too. I'm going to open up GIMP right now. I updated this computer and it closed everything. So maybe if I open this up and I leave it up, maybe in the tomorrow morning I'll actually work on it. I got up early today. I was able to finally order a pizza after like months of just doing my own thing here. I finally had the place to myself, and I'm like, I'm gonna order a pizza. I'm gonna sort by rating, and I got a good pizza. But it was way too big, and I ate way too much of it. So I had a terrible night. That whole diabetes for 30 years thing, my stomach doesn't like to move the food down from itself. It'll hold on to it, and as a result, it's huge. I'm a fat person, so that too. But so I ate all this food, and it just lingered all night. And so in the morning, I woke up and I was like, this not good. I took extra heartburn meds and all that stuff. It was bad. I had a bad morning. I had a bad morning. Open recent. None of these are what I'm looking for. Open. This would probably be on the desktop. I was having file server issues when I was working on this, right? Documents, maybe? No. I pretty much dumped stuff on the desktop on this computer, so let's see. Here's where my titling gets ahead of me. This would be an XCF. This is M33 schematic trace. That's probably an old one. I need to organize everything, like including the shop. The shop has become just a big pile of crap. We should do some gaming streams too. I'm sorry I didn't do one on Saturday. I meant to. I did mean to. Wait, really? Is that still around? Huh. Oh my God, where is it? Is it all the way at the bottom where the X's are? This is so many options. Oh my God, this is a mess. This is a mess. File types are just a mess. Probably be under G, right? A, B, C, D, E, F, G, H, I, J. There it is. Wait, no. XCF. GZIP? No. XCF, GZ. I'm looking for just X whatever. XCF dot, no. There it is. Okay, there we go. So now I can see that the M303 is the only thing on the desktop. Yarns, porno, blah, 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 teensy, scans, recording. I don't think it's in either of these, no. Module tester stuff, mutables, and then database backup. Clipper, M303, Bovril. All right, I don't think it's on the desktop then, which would put it in the project archive. Project, Twitch graphics. That's not right. That's business stuff. That's business stuff. Take me up one. Stream. Twitch graphics. Discord display, emote work, fan art, fonts, logo, Nixie, overlay, self sounds, VTuber, YouTube thumbnails. And then here's the template for all the YouTube thumbnails. There we go. Hey, what's up, esports? I have a question about older names, but I don't want to know the answers. Oh. Oh, the older names of what, file extensions? Oh boy, this is gonna take a little bit to open up. There's a lot of stuff in here. What's up, Gonad? How you doing? What was I gonna say? Did I have a Gonad thing that I was gonna? No, I don't think I did. Although one project that I do have to work on soon is a very Gonadian project. I have a lot of these little 3D printed emotes, like a lot of them. Actually, I still have a whole box full of them. Tons of these little guys. Way too many. Way too many of these. There's just a lot of them. I don't know what Wexo is thinking. He wants me to sell them. I don't think I'm going to sell them. I don't feel good selling something somebody else 3D printed and generously gave to me. I think what I can do is make an emote launcher out of them. I can make something that'll launch emotes in my face as I stream. Oh my God, where'd my hair go? Ooh, short hair bother. Short hair bother jump scare. Yeah, don't be a jerk. Be a jerk about my hair. Short hair bother jump scare. Are they the same person? Only time will tell. I can probably click through all these thumbnails and you can see the progression of my hair getting longer and longer, or shorter and shorter rather. I meticulously set all of these down in that box, hoping they would all fit. They do not. I still have a significant amount of these that are not fitting in the box. These are sent in by Wexo, who went turbo mode into printing. I don't foresee myself going to a con in the near future, but if I do, I could, I guess, pass these out. Take one frame from every video and make a time lapse. The hard part would be finding my facial expression in the right position. That would be something that like an AI tool would be really good for. I'd feel bad for somebody having to do all that work. I'm not popular enough for people to want to do stuff like that. Popular streamers get all the perks, man. They get people to like do editing for them and like highlight clips. I don't even get people highlighting clips. Features on BTS. I don't know what features those would be, but we do need to, I need to get back to BTS. That's something that's definitely on my big list. This is on my small list, is getting something together where I can make thumbnails that are pertinent to the project that I'm working on in for rather the YouTube streams, so that they're a little bit more customary looking, like they're a little bit more traditional looking YouTube. Because right now it's like the technical difficulties screen is a lot of the thumbnails that are chosen. So I have ideas. Just what I need is more ideas. That's just what I need. Ideas get us this: a bin full of bother remotes with nowhere to go. I do not need ideas. Ideas are for Discord. We have to get the custom tester majig creating. Oh, you know what? There's something wrong with the custom tester majig. We might have to fix that first. We might have to fix that first. Ideas with implementation. That's a little better than just ideas. It's a little better. But yeah, the whatchamacallit, the module tester is sick. It is dying. What is wrong? My module tester, sir, it is sick. You have to help me. Got to figure out what's wrong with this thing and fix it. I don't know what it is. Maybe it's probably the voltage regulator. Probably took a shit. We'll do some voltage. We'll do some voltage testing on it, and then when we do that, I need to program it to make noise. Noise. And then we need to send the noise through the mixer. Where is that? It's over here. Send the noise through the mixer and then measure the output. Yeah, the technology flew. It worked for so long that it just no longer, tech got to it. The tech got to it and killed it, destroyed it. I need to somehow put audio through this thing, and I don't have anything that can faithfully recreate audio at full amplitude, full eurorack amplitude. I could make something that would convert something, but that would still be using a TLS-74. And so, I mean, the whole comparison is to a TLS-74, so I guess maybe we can take input and output samples, and then that would give us essentially a TLS-74, evaluate whether or not our chip can handle everything the TLS-74 can. We don't know if our chip can do more, or if it can, if it can unfortunately do more, and it might amplify frequencies that we don't want. I need to know that. I need to know how to do that. I don't have an audio source to send through it to multiple frequencies at once, so we're going to use noise out of the tools for the Teensy 3 and 4, the audio tools for Teensy 3 and 4. I think that'll give us a good little idea, a good understanding, and it'll tell me if there are any huge hurdles. The only thing that I can think to do after that is to hand it over to Julian and see what his commentary is about it. So here's a prototype. Doesn't have a good front panel. You know what you're doing. You were the one that told me how it works. See if it does what you think it does, and if it does well. And then also plug it into your rack for an extended amount of time, because I know while this thing does not get dangerously hot, it does get hot, which is kind of bad for something that's not really doing all that much. This thing attenuates too. It doesn't heat up. I wonder if I really should have taken the approach of this thing and put everything through like just a voltage divider, just simple. But then, then again, if I did that, I would have to use dual potentiometers that were somehow fitting into the 2 HP form factor. So maybe that wasn't so much of an option. Perhaps I've misjudged you. What else is going on? There's not a lot. I've avoided doing tech stuff over the past couple days. I need to close the window a little bit. It's getting actually chilly out here. A lot of zoomies from the dog. I posted one picture of her absolutely bushed after running around outside. She had a great time with the snowstorm. But I have not been working that hard on tech stuff. I have been just existing for a little bit because I needed it. Need a little bit of a break from all this. One thing I do need to do still is actually do some audio, like listening and talking, and figure out if my voice still sounds okay. Because I haven't touched any of this stuff in a little while. I would like to get it off of the computer, but that ends up being a big job. Our understanding of analog is a little bit better now thanks to the Mixer project. I know what I can do in terms of authoring circuit boards too, so I can get into making like an equalizer. Sounds normal? What, just being totally burnt out? Oh, no, the audio. Yeah, it sounds normal. Yeah, I mean, it's untouched from where it has been. I just think I could do a little bit better on it. I think I could do a little bit better on it. Maybe that's not true. I don't know. Peaking a bit? I saw that. I don't know why that's happening. I may have bumped the knob. We didn't have like a LM1117 on this thing, did we? It's got like a temperature sensor and like a moisture sensor. It's got all these sensors. But we don't have a 3-volt regulator. I need to find something around here that has a fairly high current 3-volt regulator, unless I come up with something. I was supposed to get some in the mail, but they haven't gotten here yet. And we have the keyboard. The keyboard, whatever it is. Is cursing cool? Yeah, you curse all you want. Fine. The internet. A lot of places have self-censored, and I don't agree with that at all. And we're far enough into the YouTube video that it's fine. Yeah, I've never had a particularly strong love for LM1117s. I've used them a little bit. 7805, everybody loves using everywhere, but the 1117 was sort of a little bit more advanced than the 7805. But that was in like 1998, right? We've got better stuff now. I don't use the better stuff, but I don't have a particularly favorite voltage regulator. There are low dropouts that work just great that aren't LM1117s. But here we are in the world of audio stuff, and everyone and their dog is stumbling over each other to put an LM1117 into their project. And so I've got a couple of them coming in the mail that are the higher current version of this that can handle just a little bit more. That's the thing, is I can't tell you where the line is, because that's a philosophical debate and it's not a moderation debate. Moderation wants to know exactly where the line is so that they can go right up to it and find little corner cases where they can bust by it. And I know quite a lot about this because I had a board that allowed people to burn user screen names up onto it, not necessarily Twitch approved user screen names. They were the ones that got by. And so I can't tell you where the line is, because you will go right up to the line and you'll sort of dip your toe over it every now and then. And I don't want that. I don't care. I don't care. Just don't be awful. Yeah, some of the names were quite crazy. We don't need no newfangled switching regulators. I mean, the dumping less energy into power is nice, right? Dumping less energy into heat is always nice. Desert Empire, where it's raining. Oh, okay. That's rain. Rare. I was in Peru when it was raining more than they'd seen in a long time, and it was just a light mist. That's kind of what we got going on out here right now. It's just fog and a light mist. And all of the snow is melting. So everything's mud. It's Mud, mud, mud. My dog could not be unhappier about the weather right now. But when it was just snow, 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 she was doing all of the zoomies. She was having so much fun. And she got to play with her friends and just bubbly, bubbly, bubbly. This is what I mean about, like, hey, where's the line on cursing? And then we have this whole discussion about cursing. That's not really what my channel's all about. Shut up. Smack chat around a little bit. Jeez. All right. Yeah, so back to this stuff. We got our work cut out for us today. I don't know if we're going to be able to characterize this as well as I think. My nice super duper oscilloscope, all the money I spent on this thing, hopefully should be able to analyze frequencies coming into it over the audio spectrum. But in order to get that working, we have to get this working, and so I've had problems with this. So I will, we'll get to work on that in just a bit. I did get the full mixer working, and that required quite a bit of bodge jobbing. I have wires over here that are taking power to the opposite side, and it's such a dense design that moving this connection and this connection the other way around is not as simple as it seems. Quite very complicated, to be honest. So that revision, and then some of the other revisions, like making the pads just slightly smaller on this, which will give us a slightly better ground coverage of the whole thing. Those are going to be things that I need to do in the near future. Spend a lot more time in AutoCAD, and I probably need to email them because my copy says it's going to expire. I don't know if it'll just magically go back into working again, or if I need to send them an email and give them information. I don't know how this works. So, and I keep telling you guys about this and not actually solving the problem. This is what's happened to me, like with prescriptions this week, is that I got a text that said, hey, we've filled your prescription. I'm like, oh, cool. I'll pick that up one of these days. I'm like, it's snowing. I won't do it. Oh, I got stuff going on. I'm not going to do it then. I don't know. I'll get it eventually. I'll get it when they text me and say I've only got 8 days remaining with the prescription. And then all of a sudden I get a deluge of texts. And it turns out a bunch of my other prescriptions came in. So in my ineptitude and my inability to actually focus in on the problem and solve it, and therefore my leaving it alone, it actually solved itself and everything's syncing up at the same time. So now I've got a bunch of prescriptions that are ready to go, except for the one that I've submitted that I'm waiting for word back on. And then they sent me something that there was a problem with one of the prescriptions. So I meant to get to the bottom of that. That usually means calling the pharmacy and getting an actual person on the phone and saying, hey, what's going on? But again, in my ineptitude and unwillingness to act on this, they filled that one too. So everything is ready to go and perfectly working fine because I didn't do shit. Woohoo! So that's happening on a couple other fronts that I need to kind of get ahead of. Yeah, task failed successfully. It is rainy and it is foggy outside, so we're good to go inside here. Laziness wins again. Much to the chagrin of all of those around me, laziness has won the day. This is the wrong direction. I need the 1 stereo to 2 mono. We didn't have that, did we? We didn't have that. I didn't have 1 stereo to 2 mono. Oh, but we made that. That's what's over here. All right, so we do have the output monitor. That's this one here. This is like the crappiest way to make a cable, but yeah, we did it. I'll get started in just a minute here. What am I forgetting? What am I forgetting? That's always the question in the back of my mind. There's always something. Always something. What did I forget to do? I made so many adapters last week. The Desk of Doom has already eaten most of them. What are you working? You're working on your stuff. That's right. Yeah. What I need to do is get my steering wheel out from below the desk over there and 3D scan it. Why did I buy a 3D scanner if I'm not doing anything with it? Stuff will come up. Stuff will come up and I'll be able to use the 3D scanner a couple times before it becomes useless. Right after getting the 3D scanner, a friend of mine texts me And he says, hey, do you know anything about 3D scanning? I have access to one. And I'm like, cool, thanks. Scanning stream. We already did the one. We did the one, and we got pretty good results. I mean, I sent you that middle finger STL file. That Shortlurker was saying that I should print it out like huge and then scan it and then print it and then scan it. But I think it's just going to start looking more and more like a potato if I do that. It'd be useful to compare the two. I'll have to see if I can get him to, because I sort of dug into that. I'm like, why would you want a 3D scanner? You don't do anything with like three-dimensional design or engineering or anything. And it turns out it was for a debate on a forum. If you want to know how Bush League these War Thunder guys are that are posting classified material, that's Bush League. That is Bush League. I have a friend who is looking to rent a 3D scanner in order to correct suspension geometry on his BMW. I don't think he really knows what he's getting into, Project. I don't think he's actually going to be able to utilize it as a cool toy because he doesn't know three-dimensional design and he doesn't know 3D scanning, and clearly by the fact that he thinks he could just buy a 3D scanner and solve his problems, he doesn't know anything about that either. I had to kind of walk him through this. I'm being a little harsh. He's a very smart guy. I just told him, you're going to need to learn all this stuff in order to do this, and it might be better if you took a pair of calipers and went into your wheel well. If you took some calipers and went into the wheel well, you'd probably have better results than using a 3D scanner. If you show interest, it might end up being sent your way too. I don't think he's purchasing it permanently. I think he's renting it. If he was, he'd probably be like $1,200 out on the whole thing, which, yeah, I should position myself correctly to kind of catch that when he's done with it. But the help along the way sounds a little bit rough. I would much rather just model it in Fusion. You know, it's just a bunch of like proprietary shapes. 3D scanning, I mean, maybe that'll inform you a little bit, but you really want to, it's like, if I take the product that I got, that product is going to have variations in it, right? Because you're plus minus however many millimeters to get you into spec. And so if you do all of your, if you scan it and get it true to the scan and get the scan true to real life, it's still going to have all of those tolerances in it. Whereas if you reverse engineer it, you can be a little bit more informed on where the wiggle room is. I don't know. Yeah, that's what, and that's something that we actually did with it, is check it against the real thing. You know, I have my 3D model of the RC car that I got with calipers and that I got with reverse engineering, but then there are little things like the camber of the rear wheel, but that also depends on where the real wheel, yeah, it depends on, like, you know, what specific position this is in at the time. I scanned my driving pedals. They were way too complex to model accurately. Well, in that case, like, but that's for the visual fidelity of the whole thing, right? That just makes it more of a collage project. I didn't know 3D modeling when I stumbled my way into making my most popular model. What's your most popular model? Are you like super popular beyond my stream? What is your claim to fame? I have not listed a lot of my 3D models on things. I probably should be a little bit more open about them because I use a lot of other people's 3D models. I'm like coming into this shit like AI, stealing everything in sight and then using it for my own good, trying to claim it's mine. I guess I haven't really sold anything. I don't, you know, that hasn't happened. Again, that's part of my discomfort in you know, going to an Amazon fulfillment place and selling these. Oh, so it's embarrassing. That's why you're not giving us specifics. It's a small toy I made for something I was a fan of about 10 years ago. Oh, it's an anime thing, isn't it? It's an anime thing, isn't it? You're cagey with details. I smell it on you. If this isn't a good bother spread, I don't know what is. This is a pretty good splash screen. All right, I think we should probably get started just because we have a lot of variety of work to do here today. I am both sweating and cold at the same time. I hate it when it gets like this weather-wise. We're just in the cusp of the temperatures where certain people are comfortable, certain people are uncomfortable, and so the settings for the thermostat are counterintuitive to everything. The only way I have to cool this room is by opening the window, and then the air gets cold, but everything else is warm, and I'm under warm lights. It's weird. Anyway, that aside, I would like to do some testing. Hold on, wait, let's just back it up a little bit. It was a featured thing on Thingiverse back in the day, but I'm embarrassed that I peeked with that damn toy. Well, hey, you know, maybe you got a repeat hitting you. Maybe you go back and revisit the project. Like any media nowadays is just rehashing of old stuff. Just take those principles. Maybe you can make another popular 3D model in the image of the old one that got you popular. You keep reliving the old days. That's very healthy to do. Okay, anyway, so hi, welcome. I haven't been doing stuff for a couple days. We're coming back into the shop, re-energized, not really, having done a lot of physical work outside, shoveling snow, and all that stuff. So hopefully we've got slightly fresh perspectives, although I didn't sleep last night, so I'm maybe not that fresh. So, you know, we're fresh in the sense that we haven't worked on anything in a while. I'm trying to get this mixer project done. It's been a huge effort. There's still a lot of work to do. There's like 6 to 10 hours of just pure CAD work that I need to do in order to reverse the direction of the knob, because in one sentence of the data sheet that wasn't even for the chip that I'm using, it's a very similar chip, says that at 0 volts in, there's 0 dB attenuation, and if you want amplification, you have to go into the negatives. And that should have been my sign that the direction that the knob should have the direction that the knob should have gone in is the higher the knob's twisted, the more voltage comes out. The less voltage, the more the knob is twisted to the right, to the high settings, the lower the voltage gets until it goes into the negatives, only just slightly. That was apparently what I should have done, which means that when I was originally making the board, I didn't have to do a whole lot of this rigmarole about flipping the voltages and stuff. I did an extensive amount of looking into this to try to get it right, and I got it wrong. Yeah, it's a little TXRX thing. If I had more layers on the board, I probably would have had room to have like a little jumper that could do either plus or minus on the knobs, and then leave it up to, you know, future me to figure out which way it goes. Maybe do it experimentally at the time. I didn't do that, and the repercussions are pretty severe. But at the same time, there's a couple other revisions that I can do to the board, like lowering the size of the pads for the resistors. They can be a little tighter. This is a tight board. We want to make sure the ground gets everywhere, and so that'll help us do that. Past bother, yeah, it's always a dick, always. Okay, so in the meantime, what I should have been working on all weekend and I didn't, instead of streaming that, which is going to be very boring, maybe I can stream it. I'm not going to get a lot done if I stream it. There's a lot of head games and, you know, stuff to consider that I would have to tell you guys about while I stream it, and that slows me down. And I kind of want to get like a good circuit board ready for this. Now, the prototype is ready for Julian to test it. I want him to plug it into his rack. I want him to just do the full 9 yards with it and see what he thinks, see if I succeeded in building what he wanted to get. That will be a huge confidence boost in terms of analog circuit design on my end. The only little things that I don't really understand are, where are we peppering these things with capacitors and why? Where do all these capacitors go? Why do we have so many capacitors in these audio circuits? We got little filters and stuff all over the place. And there are probably harmonics and stuff in those audio transmission lines that you need to get rid of that I can't measure, that I don't know about. I've got a swanky oscilloscope, though. If we can get noise into the mixer and get noise out of the mixer, we can measure that noise and we can see what the chart, what the fast Fourier transform of the noise looks like. We're going frequency domain, baby. This is where the rubber meets the road and where the engineering really gets kind of cool, except that I've forgotten all of the knowledge about frequency domains, so I don't remember a goddamn thing. So what I want to look at is just what the amplitude at the different frequencies are on the output. We should see a drop off as we get into higher frequencies. That's all I can really test, except for putting Julian behind the headphones and having him listen in. I don't have a network analyzer. The data sheet says, hook this up to your network analyzer. I'm like, my network analyzer? I don't. So I looked up network analyzers, because just like any other test equipment, the what everybody's the trends. The trends are setting where the cheap equipment is, because China will just build anything. They'll just make anything that you want to if they're going to sell it enough. And so network analyzers and frequency stuff and a lot of hardcore sounding RF things are being made there for pennies on the dollar, which is great for us because we have pennies, we don't have dollars. But I looked for network analyzers. They all start in the frequencies that are so far away from audio, it might as well just be radio. They're pretty much, they start at like the kilohertz range. So the high kilohertz, not the low kilohertz, which is out of our range. It's like we're dealing with like 350 hertz, right? So, and it's like maybe you do want those higher frequencies to drop off a little bit so it doesn't sound awful. Anyway, so that's what I'm dealing with the audio stuff. We need to go in and we need to fix my frequency generator so that we can make noise, and so we can put that noise into something that can help us analyze the noise. And all I have is this expensive oscilloscope to work with. How about modulating your test signal into a kilohertz carrier? The whole point is characterization, though. Modulating onto a carrier and demodulating introduces a whole bunch of stuff that can go wrong. This is essentially where mini circuits makes their bread and butter, or breads their butter. You can buy mini circuits to do these tasks in sort of RF frequencies that are known quantity. It's like, boom, this thing works, and I know all the minutia about it. I'm going to plug it in here, and then I'll plug that into this. Then it goes to the scope, right? Stuff like that. You know your test setup works. If we build something that's modulating and adding to and subtracting from frequencies, what if what we made introduces weird stuff? Like, right? That stands to reason. I don't believe in doing that. But this chip should be a TL074 equivalent. And what I'm going for is that in all the same frequencies, this thing performs the same. So while the attenuation might be strong, one is a 10 volt signal, the other's, whatever, 1.7 volts, all the frequencies are still there, I would hope. Then again, that headphone chip that I specifically used might actually be doing stuff in order to attenuate frequencies as well. So there's actually a lot to it. Maybe we could have started this with a bit more of an engineering test setup, and then I could have, made actual frequencies that were nice and clean and perfect, and then we'd put it through the thing and do like a frequency counter on the other side. I don't know. Do stuff that would actually test this stuff. But I will be happy if we put noise into this thing, and the noise that we put in matches the noise that comes out. That's sort of where I'm at. But we start with the unfortunate thing that has happened to using this sort of hacked together setup. The module tester module circuit, the design for that is something that I've got on the back burner. It's something I should have worked on. I used the parts in order to make a frequency outputting setup. So this thing does not analyze anything. There's potential for it to do other stuff. I put a screen on it that I barely use. And I put a voltage regulator on it. I put a voltage regulator on it that does probably not have exactly what it needs to run the whole thing. Yeah, it is really kind of the Jankatron, isn't it? That's what this whole setup is for, though. And actually, it's neat. These Chinese perforated prototyping boards, they fit right up to the fasteners on a eurorack. On eurorack spacing, you can fit the circuit board in and squish it down with bolts. So eurorack itself actually lends itself to jankification. Not only that, these things, these Tektronix things that I got from a friend for free, those are eurorack height. They're a little bit meaty in sort of the dimensions that I don't really want them to be, but I could put eurorack stuff in there. I'd probably also want to just tear out the power supply and turn that into a Euro power supply. Then again, I've also got the wooden cases, so I could just use the wooden cases. I was just thinking about that. That would be kind of cool if I had like a big rack setup. I could put these giant things in there. These barely work, and they're too old to be relevant. I guess they're probably only good for a blinking light setup. Hook something up to Node Red that'll turn them on and off and give them something to display. Speakers in the back half. It's pushing it, though. when you power them up, those fans are so old. It does like a brrrr. It's kind of amazing. All right, so if I turn this thing on, I believe this is going to heat up and nothing will happen over here. Yep. Here we are again. So the main power supply, oh yeah, I haven't plugged it in yet. Wait a minute. This is still on me. Hold on. The LEDs flickered, but ultimately lost the battle. What up, Ryan Labs? How you doing? Be a cool suitcase of noise to turn up with. So future eurorack module thoughts, and something that I would love to test, is that kit of springs. If I have a small spring, it's going to be higher frequency. And like what Hedoniga suggested, if I can do frequency shifting of ins and outs, I don't know precisely how to do that. If I could use a small spring to emulate the effect of a big spring, because that's one of the old analog eurorack things. You buy this thing and it's got this big spring that's sort of this additional thing you can put into your rack. You could keep it outside of the rack because if you twang on it, it'll go blah, and so that does some really cool audio filtering. You have a solenoid inputting your audio into, magnetic energy that wiggles the spring, and it reflects back and forth in the spring, and then you have a guitar pickup picking it up on the other end. So I wonder if I could miniaturize that and do it as a 2 HP module. Spring tanks are ace. I hear they're really good, and I would love to make just a little tiny one that works sort of like a big one, so that if you bash the side of your modular synthesizer, everything goes blah, 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 but then it also, if you put audio into it, it comes out all weird and reverby. Yeah. Plate reverb. I've not heard of plate. It's probably the same thing, right? Julian's been experimenting with contact microphones, the piezo mic that you just tape to stuff, and then you can make all kinds of cool stuff with that. Oh, so when we talk about the wobulator, we talk about wobulating waves, and that's just because wobble is a really, really good word. But when you actually want to talk about the wobulator, a plate reverb is probably exactly what we're talking about, because plates, they go whoop, 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 whoop. And if you get your audio to do that, that's kind of cool. So although we love, our calling things a wobulator is a misnomer, an actual wobulator, I think, is what we're talking about right now. It's kind of cool. Okay, so nothing is happening, right? Nothing is going on over here. So the first thing we look at is voltages. I don't even see, this thing isn't even getting warm. I've already done the job of plugging this into other plugs on the back. We know that there's power on this. We can test real quick. Let's just test. And we did see the LEDs flicker, so troubleshooting starts with power. If your thing does not power on, maybe it is not powered. Maybe it is overpowered. Maybe it needs to be nerfed. So go to volts DC on the multimeter that I trust. And I plug into, let's start with -12, so stripe. And then the middle three are grounds, so I can just go to any of those. And then we get negative on stripe, positive on ground, because ground is above stripe. And it should be 12. 12.2. My God, how can I live with myself? All right, 12.2. Take this out, put it in the +12 socket. We go negative on ground, because +12 is above ground. 12.07. Our voltages are fine. We have all the voltages that we need. When we plug it in, however, it flickers and then turns off, which I think is a symptom of the power supply being bad. So what I can do is I can take a ground lug from over here. So we'll ground reference our other probe. And I can check to see if I'm getting 3 volts on the outset here. I am not. So let's see. SEK, blah, 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 and then VIN down here. 0.075 volts. So let's do a double check on this. And let's go to ohms. make sure that something wasn't severed. Good show, by the way. Be in over here. $10K is not a lot, and that's 12 volts, and we're not looking at 12 volts over here. We're looking at 3. Here's where voltage comes from over here, where the magic happens. 6 ohms. It's quite a bit of ohms. 10 ohms is not so bad. 2 ohms. Okay. So the connection presumably is being made. I think it's the voltage regulator is overwhelmed. It's had a couple days of being a little too warm being powered. I think maybe we pushed it to its very limits. That's my running theory anyway. That would be all the way up here. This part of the board that I haven't looked at in a little while. Hold on, I got to tilt it down in order to... Everything's falling everywhere. So this isn't really an LM1117. It's sort of something else. But, I mean, it worked for giving power to the rest of the board. Got some funky connections going on over here, and then I put a piece of desoldering braid at the top of it to act as a heat sink. But I have a feeling this thing just overpowered and no longer really functions in the way that we want it to. So what I need to do is get that out of there, and I guess that means getting this thing out of the rack. And then we need to find some kind of a bulky edition of the LM1117, because I need that 3 volts. That 3 volts is for these guys. For these guys. I don't think these function at no, they output 3 positive, negative 3 volts. Lunatic live rating with a party of 27 Twintington individuals. How's it going, Louie? How you guys been? Been watching. I saw a little bit of Djibouti's stream, but I kind of veered over into Sark territory for a little while last night. Boy howdy, we've been working for a little while, and I haven't streamed in a little while. We had kind of the snowstorms here, and I spent a little bit of time playing with the Corgi and just not thinking about electronics because I was so burnt out on all this stuff. We've been working, we've had like several fires going at once for quite a while in this stream, and they're sort of in service of building a modular synthesizer. My buddy comes to me one day and he calls me and he goes, hey, I got a project for you. And I tell him, fuck off. Like, I don't need more projects. It's like, all right, but I've been thinking about this one for a while. Can you build me a mixer that fits in 2 horizontal positions, that does 2 channels of stereo mixing and has 1 headphone output? And that's basically the Bother's Stream mixer. It's essentially, if him and Dave, my 2 synthesizer buddies, come in with all their gear, they want to be able to plug into a stereo input to my setup. So I've broke out my old podcast mixer. I have 2 of these things. So that one sits over there now permanently, and that one is Julian's input. I can run multiple channels of audio to this computer and deal with them in OBS. So those 2 channels he needs to have his master mix for, and then I can monkey with it from there to get it to work perfectly with my setup. But he has those 2 channels leading his synthesizer. He can balance himself with Dave and then turn it up and down his own audio as a whole. What that requires is basically if you plug in 1 stereo channel, it goes to both as well. That was another feature I forgot about. Putting that together in 2 eurorack modules is kind of a little bit difficult. We're dealing with a couple different philosophies and a couple different sort of system things that have to go on here in order to put together a 2 stereo channel mixer in 2 horizontal eurorack positions. Eurorack is a standardization of synthesizer equipment. If you don't know, a synthesizer has a couple different components to it. You have the thing that makes the actual wave, the voltage controlled oscillator making oscillations. So boo, and then you give it a little lower voltage, boo. But what's giving it those voltages? Well, for that, you can have low frequency oscillators, you can have high frequency oscillators, you can have sequencers, you can have a MIDI input give you that voltage that'll then translate into a waveform. But waveforms are boring. Waveforms are beep, boop, beep, bop, bop. Who cares about that, right? Where really the stuff, where the shit hits the fan, is when you actually add musical filtration to all that stuff. And the filters are sort of this vast swath of things that can affect your synthesizer. So sequencers, control voltages, oscillators, all that stuff goes together to make basically a big automated thing tweaking all of your knobs. And that'll give you the cool sounds you get at the output of a modular synthesizer setup. And those cool sounds we are then attenuating so that you don't blow up your headphones. What Eurorack figured was, hey, there's all these different standards for like synthesizers. Let's make one more. And so they made Eurorack, which is a particular height. It's 120 millimeters, I think, about, because it's about, you get a little over 10 millimeters in here, or sorry, you get a little over 100 millimeters in between the rails, and then the rails are 10 millimeters. And you have bolts in the center of them. They can be external bolts, internal bolts, whatever, and they have a particular spacing. It's like 10 point something, 5 point something millimeters per rack unit. And this didn't come out of nowhere. This actually came from test and measurement equipment. So my world of test and measurement equipment, and actually specifically the 19-inch rack comes from Telcom. This, I think, is the Eurorack, I think, is more like instrumentation. So if you're going to build a custom instrument in order to measure something in your job, and you're an engineer, you typically would make it in something very similar to Eurorack. Eurorack also implemented a power supply that works universally across all the modules. Now there's two sizes to it. One size introduces 5 volts and a couple internal routing signals. But generally, we're dealing with a 5x2 square connector. The top 2 pins up here, those are positive 12 volts. The bottom 2 pins, which I guess really I should have said that those are the top ones, but have this stripe on them. The stripe indicates pin 1 on a IDC, on a flat cable. So pin 1 is your stripe. In Eurorack, the first 2 pins, including pin 1, are -12. So you have -12, +12, sometimes 5. I built this little rig in order to test these panels out because I have a lot of Eurorack modules. I got swindled into this crap because apparently people put the circuit boards that make up these modules on the internet, but they don't give you any information. They say, look, the person who designed this, they went crazy. They're in prison now. It's always some crazy-ass story. Like, there's some just insane stories behind these module makers. Like, oh, this person went insane. This person posted some really crazy crap on their website and got canceled. This person transitioned and is now living a completely different life. And it's like, huh? And you got to sift through all this garbage, all this drama and garbage to find these circuit boards that people basically have the designs for free, but you buy the circuit board and buy all the parts, and then all the design documents are there, but it doesn't give you much information. I love this. This is like amazing for me. This stuff is amazing for me. There is actually somebody like that. Yeah, I designed this PCB wall high. There's one guy that does a new module every month, and he's like a doctor. So he does this weird, the trace layout on the boards is insane. It's just basically like, I need to connect this to this and this, and they're mad. They're just completely mad. I love them. But anyway, so the point is, you buy the circuit boards and they go, good luck, asshole, and poof, they're gone, right? And so you have to build these things. I love that because I've been able to scramble together a $700-800 modular synthesizer module for like $75, and a lot of skill went into this and getting it working again. I was like messaging YouTubers like, I don't know what to do. It doesn't work. It turns out my soldering was shit, which is really weird. Everything on this board was built so small that it looks like normal soldering, but it's actually a lot more difficult than it looks. It's actually a lot more difficult. So I got this one working, which was pretty cool, but then it came to tuning it, and I was like, I don't have anything to tune it with. Like, what do I do? I guess you can tune these by like musically tuning them. I have an oscilloscope. I was able to measure it a little bit with that. But so that brought me to trying to build a modular synthesizer testing module. And that's what this whole setup is. I built a little power supply here that can provide all the different voltages. I put gauges on it so that we can know when something's running away with current. And then I made a whole setup to test whether or not I could get signals in and signals out of a particularly powerful microcontroller. That all worked. But then, time moves on. Julian requested a mixer project. I have 2 people's like synthesizer modules that broke that I need to fix. So I decided that I would just roll the module tester into an output, a signal output. I'm still working on the design to make the full module testing module. It's a lot of stuff. This is a lot of work that I'm going through right now. So what we have here is a module sort of testing module. This is a frequency maker. I can program this manually and make it do a bunch of different stuff. What we want to make is noise. Because if we make noise, I can then send the output of this thing into the mixer and have that give me like a chart of the frequencies that it sees. The mixer project is its own monster that we're just getting through, and it's the thing that we're testing right now. But the mixer project is the PCB for it we did in Fusion, Autodesk Fusion, and it is very dense. This is the size of my fingers. This is 10 millimeters wide. There are components on the top and components on the bottom, and they are very, very dense indeed. And we've got it working. It works. The only things that I don't know are the chips that I used up to the job. And is this getting too hot? Because it does get quite hot when we use it. It uses a headphone amplifier that apparently uses quite a bit of current. That's a picture of a muffin. That's not what you think it is. It's a muffin. So yeah, the headphone amplifier is down here, and it's got all these little holes to translate the heat to the other side of the board, but there's just not enough like coverage of copper material to bleed off all of that excess of heat. Whew. So what we're doing is we're trying to get this thing to work, first of all. Second of all, to output noise. It's just going to require a little bit of microcontroller programming. It's not even that complicated. There's like an audio engine for this chip that allows me to just use blocks to program it. Oh, and the other thing that I didn't note to you guys is that with the eurorack stuff, you've got all of the physical like parameters standardized. So you can say like this is 2 rack units, this is 3, 4, 5, and they all fit together in people's setups, right? And you plug them into all the same standard power. Then all of your voltages, all of the amplitudes, all of the very low amounts of current, but all of that is also standardized so that if you plug an audio signal into a control voltage, you're not blowing anything up. And so since everything is 12 plus or minus 12 volts, eurorack works within those bounds just a little bit. Most of the chips don't go full rail to rail. They're like a little bit off of each power rail. When you draw schematics, you do like a power rail on top, a power rail on bottom. At least that's the way they used to do them back when there was plus and minus voltages. So following that standard basically means you open up the field to a lot more actual like functional and cheap chips when you don't have it go full positive to full negative. So they're in just a little bit from that. Positive and negative 10 volts is typically where your audio is going to be because you get all that clarity. You get a huge amount of clarity and there's just no ability to push anything. You're not pushing like a real speaker with it. You're just manipulating voltages so that they can be referenced. And so plus minus 10 volts, plus minus 5 volts for control voltages, sort of. And then you have a gate signal. So if you want to set something off, you have something that just basically says go. And that go signal is usually 0 to 8 volts. Doesn't have to be. It can be all kinds of other stuff. We've plugged in full 10 volt spread waveforms into a gate input and had it still work just fine, right? That's the whole thing about it. It's a walled off garden where you can do no wrong. I hope everybody's up to speed because my voice is totally wrecked from that. All right, so establishing all that stuff for the lunatics and for the people in here who aren't familiar with that kind of stuff, we need to get this thing working again. When I plug it into power, we do not see big voltage swings from the monitors out here. Is that on? Yeah. Turn that on. Nothing happens over here, right? So the question is this thing actually connected to power? So we go to the voltage regulator and we do a couple tests with a multimeter. We could use the scope for this, but the multimeter is really better at this kind of thing. Put this aside. So go over to voltage and I plug in to ground and power. So I can get ground over here with this clip for the scope. And then I can take this to the microscope. And then we can see where that power is going. Oh, it's a physical focus. Focus your microscope. This is the voltage regulator. It looks like total crap right now because this is a perforated prototyping board circuit. Perforated prototyping board circuits, you're not going to find the best engineering in them. Sometimes people put special care into getting them to work just right, but look just right. I didn't do that. This is a little bit more free form. I can't believe it's gone all the way to 11.9 by the time it gets over here. And then here's the output. This should be at 3 volts. It is not. And this is ground. There should be nothing going on here. Nothing's going on there. This one probably also ground. So that's interesting. But we're not seeing 12 volts on a 3-volt line. So our electronics presumably have survived. I think that it's the voltage regulator that has gone wrong. I think it's wrong. Darn. Okay, well, we got to find something else. We got to start sifting through all my parts. We need to find a 3.3 volt regulator that is going to survive the amount of current that this thing draws. This is built out of some what's called I2S. Listen, guys, I know a lot about a lot of stuff. And the synthesizer stuff has introduced me to this whole world of audio engineering. What's happening basically right now is what I used to be used to, digital stuff over here. You know, we used to make joysticks and stuff on the stream, but doing this audio stuff has really pushed me. This is what's called a Teensy. This is a Teensy 4.0. Yeah, 4. Is this 4.1? Is the 0.1 the smaller one? Whatever, anyway, Teensy 4. This is a blisteringly fast microcontroller for what it is. It's a $20 microcontroller platform. I use them on a variety of different projects. That's why for this thing, this temporarily built semi-permanent circuit, I've got it in headers so that I can transfer it to other projects in the future. Now, I think the final version of this is going to use the larger Teensy. That's going to be a trip. I don't know if I'm going to use all the channels or not. I got to decide what I want running that project, because this thing is well more than enough to run a testing setup. But anyway, so that thing digitally communicates with a screen. I haven't figured out a menu system yet, but I got buttons that I could use. I included buttons in the build because I don't know. I think just because I've lost control. And then it communicates digitally to 3 of these stereo modules. And these stereo modules can output up to 3 volts, positive and negative, because apparently this thing makes its own negative reference voltage. Don't know what that's all about. There's all kinds of stuff to this that I don't understand, but these speak a language called I2S, which is a digital audio format. It basically sends like a point, and it has a stereo clock that flips it from right to left. So 2 channels in each of these, and then these connectors called Thonky Kongs for the output. Thonky Kong is not actually the name of the connector. It's, I don't know, E6 something or other. The actual connector, you can find the regular part number, but if you want to get them cheap, you can just buy them from Thonk Industries. Wait, are these numbered? What is that? H2, G3, F4. Huh? I know I didn't print a label that small and actually label these. Do these have like unique labels on the sides? That's totally new to me. That's totally new and kind of freaks me out a little bit here. I didn't know that these had like specific labeling. Weird. I wonder if they do that just so you can differentiate between them. That's not something that's that common. So anyway, the point is, this little I2S thing will make plus minus 3 volts. That is not the plus minus 10 volts of an actual audio setup. So under this chip is another amplifier. And at that amplifier, I have potentiometers that are dealing with the gain, and it's been given the full voltage. So that will bump the signal up to plus minus 10 volts, and then I can send it on to other equipment to test it out. This thing is also able to produce DC voltage levels and noise. So what we want it to do is produce noise, and then I can put noise into the mixer, and then we can measure the noise at the input and the output and compare them and figure out if my mixer mixes properly. Then I can give it to Julian, and he can complain about it. And then eventually when Louis gets into modular synthesizers, I can send him a couple of my modules. And he can go, whoa, these are super duper cool. I've never done this before, so I'm automatically positive towards them. And then people will buy my modules and I'll become rich. Things that will not happen. Anyway, we need to replace the regulator on this. So we need to find one. So we're going to search through parts that I have. I have a lot of parts sitting around. I also have a lot of circuit boards sitting around. So it's possible that we could take this voltage regulator off of something else. Although we've had problems with this before, where I've gone to get the voltage regulator off of something and it's not the right thing, or this and that and the other thing. Let's do a little bit of soldering first, just so that I can keep the people who are still awake awake. Did I miss a wonky robot, or is chat just that quiet? Oh no, I didn't. Spring tanks is what the comment was. Yeah, so all my stuff is still working. Good. All right, let's get the old one out of there. For that, what we're going to do is we're going to get a lot of heat into this area, because this voltage regulator is set up to dissipate all of its heat. It's kind of important that it does that for the longevity of the chip. And if you've seen this thing running in the background over the past couple weeks on stream, a lot of heat over there. I wasn't able to handle it. So I could put a more powerful 3-volt regulator on the job. There's always the question, though, when you do something like this, is if I do mix it up and put a big 3-volt regulator here, is it going to blow something up? Because you've suddenly given it enough oomph to actually kill something instead of going into a safety mode. There aren't exactly LEDs on these things that tell you when it's gone into a safety mode, as opposed to just died because you ran it too hard. So there's a possibility that this thing blows up, takes everybody with it. I don't think it's going to happen, but so we just, the iron is not on, as seen in thermal imaging. Boop. You gotta wait a little while for it to heat up. Okay, it's heated up. This is a professional 300-watt soldering iron. I don't mess around with the solder. I use it like every day. We should probably put something under this, actually, so I don't melt I don't want to melt my desk. How's it going, lunatics? I've seen that Louie's been playing a lot of really retro stuff lately. What's going on? We just had, what was that show? The Sony show? With some cool-looking side-scrolling stuff. Side-scrolling gamers, man, are eating good these days. They are eating good. I'm new to all this. I'm just trying to absorb. I hope that wasn't too quick. I live in this stuff, so it's oftentimes I'll explain something and it'll just be way too much information all at once. I do need to go slower, but I'm trying to get to work today. That's the problem with streaming. With streaming, I want to keep everybody like informed as to what I'm doing. And if I were to do that like really effectively, I would be talking way slower. But instead, you get ADHD-addled bother rifling off details at 1,000,000 miles a second. Just because I'm trying to get through that explanation so I can get to this, which is the removal of the old voltage regulator. These 2 pins in the middle are both connected to ground, I believe, which means that the tab over here is also connected with those 2 little pins. So if I heat load the whole thing, there should be enough heat swimming around here that the added heat from the tip of the iron is enough to get to the big tab from here. So if I just hold that there, and you can see it bubbling the stuff on the other side. Sorry about the lighting. If I just hold it here a little bit, yep, there it is. I can just flick the whole thing off of the board. The beauty of surface mount electronics. So I'm going to get a little bit of flux, or sorry, a little bit of goof off in here to clean up all of this excess of flux from all the solder. So it looks a little nicer. Do that. I use goof off. Goof off is kind of like acetone, but it's orange flavored. Get a couple of these over here. And then, where's my goof off? Oh my god, my mic is caught in the probes. Yeah, so we do a lot of like circuit stuff here. I've been doing a lot of audio stuff, which is why we have kind of a decent crowd these days. Did a lot of audio stuff lately. We've been learning about analog. I am typically somebody who does stuff digitally. A lot of the stuff that I really love to do is in relation to interactivity of chat with the physical world. I like to allow chat to do stuff on my stream and give them the ability to do so. Now, a lot of that has dropped off. I actually don't have anything for chat to control. And so we'll be turning that around in like this upcoming year and getting things working again. The big pièce de résistance around here was called Burn the Subs. It was a giant board on my wall where subscribers to the channel would have their names burned when they subscribed, and every time they subscribed. So somebody would subscribe and I'd go, oh, hold up, let's get this name on the board. So nothing would get done around here. We've had a couple years now. The pandemic kind of struck and things got a little weird for working on Burn the Subs. But we've had a little bit without the board. And so I'm working on getting back to it and getting that interactivity layer. The things that I'm working with right now, it's called Node-RED. I'm trying to get the Twitch API Node-RED running, because when I do, that means I can deploy a bunch of little devices on my Wi-Fi that will have interactions with them. And one of them that I'm thinking about is launching a physical emote at my face. Have you worked with any expressive ESP32? Not expressive specifically. The stuff that I do is either Tasmoda, or in the past, I would have things that log in to the, hey, what's up, Madam? Things that would actually log into the Twitch API on their own. Burn the Subs was its own entity, and it would just use the API, and it was Python programmed on a Raspberry Pi. We'll keep the Raspberry Pi, we'll keep the Python, but instead, we're going to register ourselves as an entity on the network and get sent HTML from Node-RED. So Node-RED will say, hey, I got the screen name for you to burn, and my board will go, oh, cool, let me add that to the database and burn that. So I got an ESP32SC through a few days ago, and a dev board with a screen. Nice. Find some tutorials. You'll want to start with the easiest thing to do, which is just throw code onto it and hit go, and then the little logo shows up on the screen, right? That's it. Louis did a whole bunch of emote stuff on his screen, but chat had a lot of points, so things were going off like crazy. It was the funniest thing ever. That happened to me. That similar stuff would happen to me. I used to have the fart box, which is actually right over here. Hold on. And I'll get this is one of the first things that I'm going to get running again, because people could spend their channel points and set off a physical fart noise in the shop. This is a joke store. I say joke store like I've never had a fucking dollar store around me. It's like Rich Evans and his dime bag fart bag. This is my fart bag. No, but so anyway, there's three mayors sent me, as a Twitch user, sent me a dollar store fart noise maker, and it had 9 farts in it. So we took it apart and we discovered that it was really easy to set off the farts with a transistor. And so we hooked that up to what's called an ESP8266. That is this unassuming little tiny microcontroller platform. I have them right here. I can just grab one. ESP8266s cost very, very little. They're like the Raspberry Pi microcontroller. Microcontroller is just something that allows you to run a sequence of code, and you can make them do very complicated things, and certain microcontrollers have certain features. This unassuming little one right here, you can see, has an antenna. So not only is this thing cheap, but this speaks Wi-Fi. So I can make something that gets up onto my Wi-Fi network and looks for some kind of a triggering signal of some sort. So I did that with this. This thing, well, actually, you know what I did? What I did is I made this thing log into the Twitch API. It went all the way into the Twitch API, and it looked at my channel points, and it said, hey, if there's any channel point redemptions, you got to let me know. Twitch goes, all right. And so when people redeemed channel points, it would set off one of these fart noises randomly. So as Louis described it, Lunatic Live was watching the show at some point. He was very impressed with what we were doing here, and I guess he still is, and I'm happy. I'm super happy for it. I love him to death. He came in and was like, yeah, it's the, oh, what was it? He was describing it to Justin on Djibouti show, and he said, yeah, it's like it makes farts whenever somebody redeems a channel point. So whenever his butt's on screen, there's a bunch of farts. And I'm like, you had to put that last little detail in there, didn't you? So every time I would turn around, people would set off like an avalanche of farts. When I get that thing working again, it might be going 24/7, because I didn't have it deactivate off stream. So I'd be sitting here in the middle of the night working on something, and there would be, I'm like, what the fuck? A couple heart attacks were caused because of that. I hear PubSub on the Twitch API is going to be depreciated in April. I heard that too, and I don't know what I need to do about that. I'm trying to use Node-RED. Node-RED is a like a server-y kind of thing. You run it on like a Linux machine or a Raspberry Pi, and you log into it. And so on the browser, you get this wonderful programming API that uses flows of information. So you will have something like an HTTP node that gets called by something else, and that sets off this flow of Java signals from one thing to the other. And so what I had is a Java flow or whatever that's supposed to log into the Twitch API. I'm not sure if it uses PubSub. I think it uses the good one. Oh my God, hold on, I'm hiccuping up my whole fucking face. Let me just, give me 1 sec. I'm not gonna have any organs in my body if I'm not allowed to take a sip of water. Hold on. I found a no-red node that supposedly does all the Twitch stuff. And I can't for the life of me get it to frickin' work. I can't get it to work. I don't know what it is. It's something, you know, I'm doing all the stuff correct. I'm registering all of the elements, but something ain't doing. So I'm not the best person for advice on this. I keep messing it all up. How did anything work? Nothing works. All right. These are little cases that I keep surface mount parts in. The only thing I know to search for these is WenTai, W-E-N-T-A-I. But if you look up SMD storage bin, you can rifle around and actually find these. These clip together. And so I clip them together in these little groupings of parts so that I can search for various chips. Okay, here's a MISC SMD, and we have this unassuming voltage regulator looking mofo. We don't know what this is. We may never know what this is, but what we can do is we can take a look at it on the microscope. Let me just get this bin out of... If you drop these on the ground, they explode into about 10,000 tiny parts. So it's very important to take care to put these away before you move on. Otherwise, I'm going to end up nudging it off of the desk because in a shop like this, any open, upwards-facing surface gets filled with crap. And as such, it's like that coin game where another coin drops down and then the platform moves and you nudge one back of a coin and 50 coins fall off the front. That can happen here. All right, hey, thank you for participating in chat. I appreciate you keeping that part of the stream alive. It's things get quiet in the middle of the day here, but you know, I know everybody's here. A lot of people like to turn on my stream and have it running while they're at work. So, all right. So anyway, we can know what this chip is by looking up the part number. I'm going to keep this at a pretty basic level today for anybody who's watching who's a lot smarter than me. So 317MG RXF46, because it's, well, I'm not super familiar with ON Semiconductor. This is on, I've been doing this stuff for so long and reverse engineering for so long that I know the logos of the manufacturers. Even through the years, I know an old ON Semiconductor logo from a modern ON Semiconductor logo. We've gotten better at printing stuff on chips. Those lasers have gotten more capable and smaller. And so instead of just like a number, we can have a logo and a number. But anyway, so 317MG RXF46. We don't look up the whole thing. We probably can just look up 317MG, but we're in the weird world. Oh, I don't have a working window open. The browser extension for Chrome that blanks out your initial page is so important. You guys would have learned about so much weird porn if you guys could see my browsing history on the front of Google. Okay, so what we're looking at, oh my God, what we're looking at is the initial part of the part number, either on semiconductor or the package. But what I mean by package, you're looking at two packages right now against your will. This is why I'm going to get canceled. You guys are just staring at these packages. These could very well be the same exact chip inside. It could still run to the same number of pins, or there could be just a non-connect pin. The packaging is what the chip is surrounded in. It's the epoxy structure and the pins. And so SOT 223-5, I don't have an example of, hold on, where's that? SOT 223-5 is an SOT 23, so the transistor looking 3-pin box. This one doesn't have any. This one doesn't have any, but with 5 pins. So that would be this guy right here. This is a slight variation. It's smaller in every dimension, which is really annoying to look up. But you have a limited number. So M7Q, and then you do M7Q SOT223. You might add the 5. Actually, this might just be 23-5. There's all kinds of designations because when a manufacturer goes to make something weird like this fucking thing right here, they'll make up their own. They'll just make up their own. Or if two manufacturers have some very similar chip dimensions, they'll sometimes make up a similar part number that's different. So it helps to look up the package to narrow down your search, but it also might kill your search because there's too many standards. It's really annoying. So this is a larger chip. It's not specialty. It doesn't have a weird layout to it. This is going to have a specific name, and I should remember it because I just added it to my CAD software, but I don't. So what I'm going to do is I'm going to look up SMD package types. And this is actually, fucking don't trust AI on this one. This is actually a variation of our old favorite voltage regulator, because there are certain parts that are called jelly bean parts that everyone doing electronic stuff should probably have access to, because they are some of the most commonly used things. And when you get into professional electronics, you find that they're using a variation of the common electronics, because that's where they started too. You start out with these jelly bean parts. And so the jelly bean part that originates this voltage regulator, although, I don't know, maybe it's a little different, the 7805. And the 7805 is a lot of different manufacturers that make them. This was the original voltage regulator. You find these in very old products. If you're dealing with either a really bush league, like electronics device, you might find one. This dumps a lot of the voltage into heat. This basically dumps all the excess voltage into heat. So whenever you're using a 7805 in your project, you'll know it because it gets hot. And so you can find these in stuff from like the late 80s, the early 90s, some like, maybe not Nintendo, but some other places. But anyway, the design for the next generation of voltage regulators sort of originated from that. Hey, what if we made this a little smaller and we just put a little bit of the tab up, because we'll solder the tab to like a big trace. And then maybe we don't need all 3 pins here because we've already got that tab. So what if we just remove that pin? And so yeah, that's where the miniaturization has gone. They're not very creative is what I'm trying to say. But that's the 7805. That's a very famous voltage regulator. I've got a whole bunch of them. I like to never use them because they make a lot of heat. They do sure make a lot of heat. So what is this one? This one is a nice old thing. I'm going to go 263. TO263. It could be a 268. Let's go TO268. So if we look at 317MG TO268. Actually, the LM317 is a pretty famous voltage regulator. Yeah, adjustable output voltage regulator. So we need to tune this to 3.3 volts. And I think I'm fine doing that because I think it'll handle, let's see, adjustable 3-terminal positive voltage regulator capable of supplying in excess of 500 milliamps. What's the LM1117? No. I don't want to start a whole thing. LM1117 data chart. 800 milliamps. So yeah, we're not using this one. This one is pathetic. Who snuck a pathetic voltage regulator into my collection? This thing is useless. All right, I'm not even going to put it back in the bin. I'm throwing it out. I don't need this. Spaghetti-O, where do I go from here? Well, maybe we can get a 3-volt regulator that's a little bit more powerful and it's not quite on the chip level. Maybe we can get one from out of here that does the job properly and gives us enough amps to run this thing. Because this is only a temporary setup. We can just put a pin header on it. That is assuming I can find a 3-volt reg. This actually is an 1117, but the 1117 wasn't enough. So we're not going to use that. We need one of these Pololu ones. If you're looking to build a robot or you're looking to build something like a system setup and you don't want to get bogged down in figuring out whether or not your voltage regulator is correct, or you don't want to make a PCB for it, you want to solder it to something like some wires, Pololu sells these little voltage regulators that are really kind of amazing. They're using their a proprietary chip, which is just in their schematics. You can reverse engineer this very easily. They have schematics that you can look at. It's this chip right here. I forget who produces it. It requires quite a bit of extra componentry in order to do its job, but it could do its job really, really well. And so Pololu sells these little boards. I've bought a bunch of them. I love them. You basically give it the V in, the ground, and then you get the V out. You can turn it off, with a signal, or you can give it an LED that says the power's good. Just make sure that there's no marking on the middle of this one. I've blown a couple of these up. This thing should be good for like an amp, if not more. I think it might be good for 2 or 3. I don't know what voltage this thing is, though. So Reg 17A. Step down. We got 12 volts coming in. We want 3 volts going out. So my insulin pump is clicking a lot, and I don't like that. The clicking is very distracting, and the back of my mind is going, you are using too much insulin. Why do you need all this insulin? So they're using the intersil regulator, ISL 5140. And so we need to figure out what the configuration is. It's 1 amp. Okay, 1 amp should be okay for us. We're going to we probably have to modify this. R2 and R3, it looks like, are the 2 resistors there. The coils, that big ass coil. C-boot, CV in, that's fine. Our variance is going to be R2 and R3. So R2 and R3, that's various voltages. R2, related literature. Okay, let's see. Here we go. R2 and R3, V out 3.3. So we need 90.9 and 20 kilo ohms on R2 and R3. And I have a feeling that this one is going to be something like 90.9 and 12.4. 91.3 10C. What the hell? 10C is a coded resistor. For those of you that don't know, if I'm still communicating with people who are interested, those of you that don't know, the resistors have a code to them. The reason I like surface mount resistors so much is that the code on the resistor basically tells you exactly what the resistance is, but they've only got like 3 or 4 digits that they can print onto the top of resistors. What they do is the first 2 digits are the numbers and the value, and then the last digit is the number of zeros. So if you had a 91 ohm resistor, you would have 910 printed on the top. So this one is, and again, we looked at the data sheet, R2 is almost universally 90.9 ohms, right? So we have 913. 90.9 is very close to 91. So much so that it really doesn't matter. So much so that it doesn't kind of matter. There's a lot of statistical probabilities in the values of components because they are manufactured in about 1 billionth of a second. So you're not going to get the most accurate stuff, nor do you need the most accurate stuff, especially in digital electronics. You're like, is it 100 ohms? It's fine. It can be 90. It can be 120. Really, when we're building analog circuits, we like to use 1% of tolerance. But in this case, this is probably a lot less than that. Oh, good. I'm getting weird measurements. Just what I wanted. Just what I wanted when I've got all these people here. Oh, this is... No, it's in ohms. It's in ohms. What's going on? We're probably charging this bank of capacitors. Yeah, look at how the ohms are climbing. It really should be 90.9, but I mean, if I suddenly connect this backwards before these have time to dissipate... Yeah, you can get like negative ohms if you're not careful. So this one, 10C, if this is 3.3 volts, this should be 20 kilo ohms. And if it's 5, it should be 12. It's 12. So it's 12.4 kilo ohms on that one. So this is configured for 12 volt, or wait, 12.4. This is configured for 5 volts. That would be useful to us, but we are going into a 3.3 volt system. So we need to reconfigure this voltage, this voltage regulator to be 3.3. So we need a 20 kilo ohm resistor in the size of the rest of these resistors. I think these are 0603. They're not 0402. Those are evil. So 0603 is nice and easily workable by us, by our human hands, our meat appendages. So I have this whole book of 0603 resistors, and this is a sample booklet. You can buy these on Amazon. That's where I get most of my stuff, just because I practically have an Amazon warehouse up my patootie while I stream. 20 kilo ohms right here. I'm just going to grab one of those. Double check. Yeah, 20 makes this into a 3.3. Simple as. Drop that resistor down. These little reels are made to be held in like a reel holder that will separate this little piece of, not mylar, but it's just a little plastic sheet on top of it, and it will expose the singular component to what's called a pick and place. And a pick and place machine will have a little suction cup that comes down, sucks up the part, gets its orientation, places it down on the board. We're not a pick and place machine, but this stuff comes in that sort of that setup, and the little pins will help you index these things. You can actually 3D print spool holders for your surface mount components and have it all on this nice organized like thing that'll display the component for you. But I'm not about to 3D print. I'm not Wexo. I'm not about to print like 250,000 3D printed parts for this. That would make my resistor storage like the size of the shop. So the part that we are replacing is the 10C. So I'm still using the giant soldering iron tip, because what that allows me to do, well, actually, it's not really going to allow me to do it here. I just come in and get both pads at the same time. What up, Tom B? How you doing? Nice little birthday cake you got there. Okay, so we're going to go down a size and tip because I can't get it in there because of the way they design this. Otherwise, I could have gotten both pins at once, but quick change tips are fine. I'm still going to use a rather large iron tip, though. The other day, I was positioning my hands on something, and I accidentally used my fingertip to hold on to the iron, in place. It was not a good look. All right, I'm going to add a little bit of solder to this so that I get the like rosin core from the solder, and the flux will help me hold heat in. This whole thing is, the whole board is going to heat up because this thing has mega heat dissipation. And I really could put this into like a vise or something to help me work on it a little bit more easily, but we'll try it like this at first. See, that giant ground plane on that pin is going to be a problem. So just get heat into here, let my iron do all that work. I can get that other pin and see if I can just get it to move. This might be glued because we're on a 2-layer. Actually, no, we're on a 1-layer, so this shouldn't be glued. It's just going to be kind of a jerk. I haven't been streaming in a while, so it's no wonder there aren't many people here. I've violated the personal contract with you guys for not being around. Got to get both of them at once. And I don't care about the old resistor. It just goes wherever. The new one is going to come back over here, and I guess I got to clean up for it. So I'm going to use desoldering braid. Desoldering braid is just a braid of copper that relies on surface tension in order to remove solder. So if I heat this whole thing up, that solder is going to want to spread out and tin as much as it can. And so it moves that solder away and leaves me with a flat pad. I do. But the hot air gun's a little bit of hassle to get out, and it takes longer than that. Sometimes the specialized tool that's specifically for that kind of thing is just not the right thing. I feel the same way with the tweezers. They make soldering irons where you have 2 soldering irons juxtaposed onto one another as a tweezing system. I do not like those at all. Problem with those, they're so specialized that they're a hassle to get out and use. By the time you've gotten the tweezer system out, I'm already done soldering this. You can see this has just taken me a couple seconds. Damn it. If I were doing this in a factory line, maybe the tweezers would be a little bit more useful, but every single electronic shop that I've seen them at, they collect dust. I've had people in Discord like try to argue with me about this, and it's like, dude, I don't know what to tell you. It's just every single expert that I've ever talked to hates them. All right, so this thing's 3 volts, so I'm going to actually do the right thing before I move on and print a label to go onto the back of that thing. I have just the thing for that. It's this guy. So what is the input? It said 36 in, right? Yeah, 36. So we'll do small font. 8 points probably fine. So 36. Volt. We'll put a V on that. 36 volt, and then next line we'll put 1 amp, 1A, 3.3 volt. Print that. Perfect. I don't need to know a lot of information about like who makes it and stuff like that. Pololu's got me covered the rest of the way with all their markings. Well, I should use these intersill regulators in some of my designs. I might do that. The labels are very important to me because they don't smudge. Although this is a heat label and this might get hot. So that might be a little trouble. If we get to that close to that 1 amp rating, these are going to get extremely hot, which will render the label completely useless. I guess we'll just find out if that's the case or not. Yeah, I got to see what's going on with the Twitch API. I was monkeying around with it earlier. I have something that's asking for an OAuth, which I think might be a little different from, I don't know where I'm going wrong with the whole thing. I keep working at it though. Oh, I'm going to need a little clearance under this. Oh, that's sloppy. Sloppy. Oh, hey, that fit on perfectly. I didn't expect that. Nice. All right, so what we need to do over here is mimic the pinout, and I need to put a header, a low-profile header on this. And if we're working in this area, I guess maybe I can do it down. I guess I can probably go up with this. I have to. Oh, no, I can't. It's way too far. Yeah, okay. So it'll have to either stick up, straight out, or straight up. We'll go up for now. We'll have it just go up this way. And then the pinout, power good, shutdown, V in, ground, V out. So it's V in, ground, V out. So that'll be nice and simple. Look at this big skin tag here. What's that? Must have bumped up against something. Okay, so we need really a 3-pin header, but I guess 1, 2, 3, 4, 5. I guess I can put 5 pins in there, and we need to clean up this area just a little bit. This thing does not fit into a vise, so I got to work on it freehand while it floats around on the desk. Really, that ground wire is not doing anything there. I guess I can get rid of it. How did I work on this? This is a lot of work that I put into this. So how did I put this together? Did I put it in the big vise? I must have put it in the big vise. Or I had it on the that vise that Wexa sent in. The flat one. But I really need to replace. I need to get a better flat vise. One of those metal ones. Those are pretty nice. So what's going on this row right here? Not a lot. Good to see. So I can clean up this whole first row and have, wait, doesn't look right. Oh, I see. Okay, so there is a big wire going through here. So it's pretty much here that I would have to put something, and then there we run into, yeah, okay. Oh wait, but then, so that's a ground right there? Ground has to go to the middle, not the, this is our output here. Out, ground, and then this one's the input. So basically these 3 pins, but I need to make sure that this one I think that one is a ground. Yeah, see that one's got a wire going directly on top of it, which is trouble for me. If I go down, no, I can't. If I go diagonal here, or if I do, well, if I directly, no, but then, okay, so let's desolder that. Let's desolder that so I know what it is. And then we're just gonna have to jump our ground over that pin to get it into the right place. Okay, cool. Yeah, this one's not really gonna desolder all that easily because it's got a wire sitting under there. Go to the other side and try. Doesn't even look touched. Is that really the pin we're working on? Maybe not. Now, does that look open? Yes, it does. Okay, so that is the right, we got the right pin. That one is soldered there. Let's take a look real quick. That one's soldered like that. I need to free this up. Can I go here and then diagonal? What's right there? I don't know. That one is taken up by V in. This is V in. Why is it coming from over here? Wait a minute. Hold on a second. One of these is V in. Down here and over. What did I do? What did I build? What is going on? Yeah, this voltage regulator will solve our problems. It's just it's got a little bit of a non sequitur pinout from, well, no, it's got the standard pinout. It's just our previous one didn't have the standard pinout. And this one was jumping to the center pins. We don't need it anymore because V out is on that side. We've gone through a couple voltage regulators on this build. This one being the latest, having a standard pinout. The one previous didn't have a standard pinout, but the one before that did. So I don't know. It's a big mess. Big old mess. Oh boy, it's bent underneath there. I'm just going to clip it close. Oh, that one's coming from somewhere else. Wait a minute. What? That one's not 3 volts? What is it? No, I think it's just, yeah, it just skips up 1. Oh, so this is 3 volts as well. That shouldn't, no, that should not be going to everybody else. Unless it's 5? No. This is where power's coming from. And according to this thing, this is what? Negative 12 volts, which we're not using. Negative 12 volts is coming all the way up on the back here. I think it's something I can point with. Negative 12 volts all the way on the outside. So negative 12 coming up around, stops. Ground. So those should be all connected together. Ground. And then positive 12 volts. Positive 12 volts up and over to here. Up and over to here. Random blank stuff. Probably get desoldered. And then this one is ground. This is ground. So then, nice if I could take positive 12 up here to this pin. But this is in the way. Let me remove the solder from those and see what they are. See if we can use those. I didn't think replacing a voltage regulator would be so difficult, but it turns out that it is. Okay, that's open. This is open, and we're in business. Not open. What is this? Is it just crap? I think it's just crap. Okay, that's just crap. So let's see. If I jump down and over, then that puts V in, ground, and then V out all in line. And so I can have my 5-pin connector across here. So this needs to get bent out and away. So first we need to remove it from these pads. And then I need to go down sooner. I need to go erp. And then this needs to jump over top of our ground, which is easy enough to do. Once I get in here and rework it. Oh, unless that goes in there. Does it go in there? I think it would. Oh, that was the origin. Yeah, that was the thing that I cut. So it does go in there, but not very far. I should be able to lift this thing out. Solder. This is supposed to be so easy. Just make a frequency generator and do a little analysis. But here we are soldering. That's how it always goes, though. Add a little bit too much solder. That'll help me get the heat in there. What in the world? It's not moving. Ugh, that's really annoying. All right, I'm just going to cut it. I'm going to clip it up here where we need to turn 90 degrees. The other thing is I can't use anything over here because that's what the rail's going to hit up against. Here I could do weird stuff if I need to. I could do a 3-dimensional jump over the over that ground line. Come on. Ugh. Oh, there it is. It just all of that prying and it just went with the tweezers. All right. And then desolder braid. Here we go. These custom PCBs, these little perforated prototyping boards, they always look pretty rough. They're always pretty rough, but as long as they get the job done, because their whole purpose is to construct the circuit in a way that is semi-permanent, so that you know that your circuit works, and you can then move on to the CAD-designed printed circuit board. So what I'm going to do is I'm going to get some headers here. I have these special low-profile headers. They're circular pin headers. They can handle a bit more mechanically, and they can handle a little bit more current than your typical pin header. Although typical pin headers are pretty good. They're pretty good at their job. Where did my pin headers go? Where are they? What did you do with them, chat? What have you done? I can't believe you've done this. Hey there. All the way over here. Gotta go get them. Okay, pin headers. Pin headers can be kind of expensive when you're bulk ordering them. The whole point of them is to order enough that you don't remember how much they cost. And so when it goes to using them, you use them like they are completely disposable. And then you don't feel that cost later on. So I've ordered these by the bushel, and now I have tons and tons of them that I can use without nary a single thought towards the cost. 5 of these pins. 1, 2, 3, 4, 5. That's right. This thing's jaws are the most aligned of anything that I have. So they cut these pin headers cleanly. Any of the other cutters you see, like this thing is a flush cutter, so it's flush on this side, and there's all this tool over to the right. This thing does not cut them cleanly. It cuts them too close to one side. Know thy tools. Wow, the circular pin headers, I'm getting a little low on. I think I need to transfer some from another bin. It's because I got all of these regular headers and I put them in here, thinking that I'd be saving myself. Low profiles are what I use for these perforated board builds. All right, let's get 5 of these. 1, 2, 3, 4. Can you count? 5. Go. Tweezers. I would have been looking for these for quite a while. Why am I so burpy? Jeez. What did I have for lunch? Leftover pizza. Well, okay, so there's the answer to that question. All right, so 5-pin male and female header. I'm going to drop that right in here. Now hold on a minute. That's the wrong way. Hold on. I'm going to make sure we're doing this correctly. I may have to scooch everybody over to one side because this is going to plug into here. Oh, I guess I have to do this upside down. Oh no, because V-out's here. So I actually need, we didn't have to do that maneuver. We didn't have to do that. Well, no, because I need the overrun of 2 pins. Wait a minute. Where's the power good and shutdown? Are these? I got it wrong, which is not a rare thing to happen around here. I need to get solder out of these guys over here. Let me clip the desoldering braid so I've got nice new braid at the front of this thing. I wonder if the frequencies are going to be more stable now. Because remember, this thing would like, it looked like I had magic powers. I was able to wave my hand over top of this thing, and it would interrupt the output signal. I wonder if that's going to happen with a higher power regulator in here. Cleaning up some of the other stuff so it doesn't get in the way. I've had these Pololu regulators in old projects, the steering wheel that uses real car parts project. I've had these Pololu regulators contact my perforated prototyping board, and where it contacted it was its capacitors, and apparently the can on the capacitor was actually wired to the main voltage output, and it took out a whole bunch of technology with it. It shorted those pins and took out, I think it was the expensive automotive communications, like whatever it is, interface. Why are these filled in? Oh, this is where the wire is, and then it stops here. That's right. Okay. So this has to fit there. Oh boy, that's going to put a damper on things. Right, I can't move it over. And V out, this is V in. This is where 12 volts is. I think. Wait a minute. Let's double check some of these things and make sure they are what they is. I'm very tired today, and the last thing I need is for things to explode. I don't think I need things to explode around here. I know it gets a lot of viewers, but so negative 12 in ohms, negative 12 to this spot, 468K, all right, ground to this spot, 0.6. So this is a ground coming in over here, this one onto plus 12. So that is plus 12. And then we know that the yellow one is negative. This should be, or the yellow one is 3.3. Ground to ground, 1.8 mega ohm. What the heck? So that helps connect, that diagonal is what helps connect it. Yeah, okay. All right, so we definitely need that diagonal in here somewhere. I definitely need that ground to connect up. Yeah, yes, this is why I bought these probe pins, is because they're very sharp. But when you move them wrong and you stab your freaking finger with it, it will draw blood. The probe pins are super sharp because you can poke them in through oxidation and get a good reading. It's a kind of an important thing, but they're also high voltage probes, so they're this freaking long. So when I try to like carry them with the multimeter, it'll poke the crap out of my hands. So that needs to be connected diagonally over to there. That one is ground and will not change. And then if I flip this in ground out as backwards, these are a whole bunch of annoying things that I got to deal with right now. So right now, this is technically in the proper orientation, I think. No, V in and V out are flipped. I want this to be over like this. If I just connect the three, V in, ground, V out, I think we're in good shape. So if I can get this to jump over to there, and then this, so if I use this pin right here, and I go diagonally from it, which means we didn't have to do all that modification, but whatever. No, but I can't use this pin. I really want it to be over here. 1, 2, 3. So let's get 3 of them in there and we'll deal with the rest. It's only going to be 3 pins on this one. This one will be a specialty. One of these Pololu regulators. So only 3 pins, and it's going to go right here. It'll basically be V in, ground, V out. And when I solder this, it's going to hurt my hand because I got to hold it by hand like this. A little bit of solder on the pins that I can use, and if I roll my finger to the side, maybe I can keep it from receiving the full brunt of the soldering iron heat. Oh, that's not the case. I didn't really get any solder on that. What's going on there? Yeah, I thought the regulator would be going easy on us a little bit more, but turns out most of the stream is dedicated to changing out a VReg. Which happens. I mean, this kind of thing happens. Bosses hate when this kind of stuff happens, though. Yeah, I had to spend a day swapping out a voltage regulator. They're like, my God, you wasted all of my time. Do you know how much I'm paying you as an engineer? I was like, sorry, this is what happens. Stuff goes bad. Stuff goes wrong. Things go sideways. All right, so we have our in, our ground, and our out. The bottom is our in. And so we need to get this here and here. And this needs to jump up and over. And that one just needs to go straight across. So for that, I'm going to use one of these breadboarding kits. Breadboard is a series of clamps, what you can use in a sort of a flat layout in order to make your circuit without solder. I've got, do you have progressives or bifocals? I don't, what do you tell? No, man. I'm looking at exactly what you're looking at. I got my OBS window right up front. So my view is your view. Microscope works for both of us. So breadboarding, you have little wires that you can plug into the thing. And since we've been through a couple kits before, this is sort of like a derelict breadboarding kit. This is all the stuff that's just kind of gone wrong. All the pre-bent and all that stuff. So from the old kits when they run out and you can't quite use them. So I can just grab a random wire in here and this thing will be perfect for wiring up the rest of this regulator. My glasses are neither. My glasses are just regular old lenses. Regular old lenses. Because I look like Ben Franklin doesn't mean I use bifocals. So we've got to cross these around each other. So I'm just going to solder this one in here. Body by Ben Franklin. That's my fate. Okay, that didn't solder at all. Well, actually, it didn't solder. This wire can kind of fight you sometimes. It's very cheap. All this stuff is very, very cheap. Everything is to the bottom dollar. Why is this not soldering at all? There we go. You can pre-tin stuff, so what you do is you actually add a little bit of solder to the end of it, and you let the solder flow onto what you're soldering. Pre-tinning helps you lower the amount of heat that is actually experienced on the circuit itself. That's good for putting wires together and stuff. Use more flux. Do you not see? Look at what you're telling me to use more flux on. Don't tell me to use more flux. I know what I'm doing. I've been soldering since you was a twinkle in your daddy's eye. What the fuck are you talking about? This is plenty of flux. Do you typically solder things bathed in flux? What's wrong with you? You're going to get all kinds of different cancers. No, this is plenty of flux to be doing the soldering. Use way too much flux. I'll tell you that right now. You know, it's easy to use all kinds of flux in a situation where you've got plenty of cleaning stuff to go around, but I try to limit my exposure to chemicals in here. It's good to use less. Every time I heat this thing up, I'm adding flux to the mix. And I'm not going to end up cleaning up because this is only a test board. So. Were you also one of the ones in here telling me that I should be drinking lead? Lead is so much better than everything. You need lead. You need lead in everything. Ugh. Oh, I'm good. Everything works just fine. Yeah, that was already soldered. All right, that's fine. That's fine for what we're doing. So this one goes straight over, and then this one jumps this one. This has to go like that. So let's get that right angle in there first. These just got a little bit oxidized because they're probably older than I am. Expose that just a little bit. I guess I can pre-tin this one. Lead is what plants crave. Yeah, it's just the opinions of lead that we got for that one day. I know a lot of people like to just be sort of like counter whatever Bother says, but I know my methods and I know them well. And I like to limit the amount of flux that I get exposed to, for sure, because it's not good stuff. It's really not good. It's not looking out for your better well-being. And it's messy and it gets everywhere and it attracts gross stuff to your boards when you're not super duper cleaning the board. You can see here there's a lot of old flux sitting down on these pads, so they should solder just fine. My wire is just a little bit belligerent, if you will. Yeah, that thing's not really cooperating. Let's see if it'll. Well, actually, we need to be over here. So, yeah, let me cut this a little bit shorter. Just a bit. And I'm going to add a little bit to the end here. Where's all the flux now? Jeez, what the hell? Why is that going? There it goes. There it goes. I guess I didn't tin it fully. And I'll just give it, hopefully without harming the connection over there. Perfect. All right, that'll be good. That'll do. That'll do. It's not as fancy as it could be. But we're not really looking for fancy here. It's going to drown it with solder. Lay down. Do. And then we'll do like a little 3D jump towards the camera to get up and over this one. I could actually do captain tape on the other side and go straight across over the captain tape. There we go. Everybody moved. We're not going to win any awards with this, but whatever. It'll do just fine for what we're doing. All right, so I'm going to get another wire because this one, well, actually, no, I have enough left in this. So if I take this with my tweezers, I just use these as a little bending form. Like that. Then we're going to go the width of the tweezers because we've got plenty of room in the vertical. So there. That's going to be pretty tall. Back down. Because I am the back down king. Perfect. All right, let's get this out of here. And clean that up with a pair of pliers, I think. Down like that, and then we're about the height of the tweezers at the end. Oh, no, I gotta come out at a right angle. Ah, it's terrible. I ruined it. I can use the more flat pliers to get that better. It's a little cat in the hat, but it'll be all right. Yeah, that'll do. This one's short. And this wire is so super oxidized. I'm gonna do a little solder pool in order to tin it. Actually, let me get a big solder. This little solder is getting kind of annoying. I think the spool is getting caught up on stuff. I should make my own. I should make a ball bearing solder spool. Just use skateboard bearings on it. Let go. Tweezers on this. Tweezies. Yoink. Oh, it went all the wrong places. It got there in the end. Don't got to be pretty. It just got to be effective. It's getting weird. It's weirdly sticky on this thing. Yeah, it's because there's too much. That's why. All right, fine. Go over there. See if I care. Out of the way. Get this back over here. We are currently working where? Not there. And the solder's getting caught on things, and I'm poking the soldering iron into plastic. It's a mess. I wasn't even supposed to do this today. There's our skip. Oh, we also need to go vertically to the other one. The minute. Clean the tip of the iron. Dirty, dirty, dirty. For all the flux that's sitting all around this circuit, it sure is fighting me in terms of soldering. And it's this wire's inability to, sometimes it does great, sometimes it doesn't. Maybe I need more heat. I don't want to overheat stuff though. When it does flow, it does fine. There it goes. See? Now it's flowing. Oh no, maybe not. Pachyflux could probably help now. Yeah, it's just not doing anything. Weird. Why is it like that? That's so strange. You don't need to flux things up. What's up, Siflit8? Hey, thanks for the sub. 49 months. Holy crap. Thank you, thank you. I don't think any of the YouTubers are contributing anything, but if you are YouTubers, well, I need to set up those alerts, I guess. I don't think anybody does. I don't think so. But if you are, you have my sincere thanks, and you also have my what is it? You can let me know that you're contributing over on YouTube, because I don't see it. I don't get the alerts. I don't even think YouTube is a way to pay me. All right, so flux didn't really help that very much. Put a little tiny bit of flux on both of the ends, and although the things are flying all over the place in this setup, this wire is just fighting, getting soldered. Do not understand it. Sometimes it cooperates just fine, though. Is it my iron off? Iron's on. Temperature's up. The tip is good. I'm making good contact. I'm holding it there. Of course, I'm losing it now. It should be trivial. And the solder should be eager to flow all over this thing. But for some reason, it's just messing with me. So I want to grip the top here and bend it down. I need to get that to be molten. And that's just going to make a physical three-dimensional jump. This isn't the most skillful stuff in the world. I'm just getting the job done. And having trouble doing it for some reason. I started working with electronics as a kid in the 1990s. Where I would take the stuff. My mother worked as an accountant with a research thing at UPenn, and this doctor was making all kinds of awesome stuff. It was all like electronics, doing non-invasive sort of monitoring using basically the same principle as one of those like armbands that does the blood oxygenation and blood flow in your arm. Using that technology, but basically applying it to your head, and so I was just tagging along for the ride because she was a working mom who worked in the city, and I had my daycare center was right across the street from UPenn. So after daycare, I would go there and I would hang out in these labs, and there would be all these parts. And so I started soldering stuff together and got in quite a bit of trouble one day. Of course, that was my first foray into electronics. My brother taught me how to solder. We kind of ran from there. I need a little tiny piece of wire. Oh, it's all the way over there. Put the bin, practically put the bin away. Yeah, it took until I was a teenager to get an actual book in electronics and start learning how to actually put stuff together. Get in trouble printing data sheets out in the library. We need one more little jump, and it's right there. And it will make this no longer look like a certain symbol that we vehemently disagree with. My grandfather thought. Jeez. You gotta watch out for that kind of stuff in electronics. These patterns of right angle lines. That's why it's not the reason, but it is a hidden reason for why I never do four-way junctions in schematics. Never do four-way junctions in your schematics. And you say, but bother, I was born and bred and raised to put four-way junctions into all of my schematics. What you're talking about is poppycock. I've worked in this industry for 10,000 years, and they've only just released me in order to tell you that you're wrong. I don't do four-way junctions because if somebody is marking four-way junctions and they forget to put a mark down, you don't know if they meant for that junction or not. So everywhere a wire crosses a wire, you go, is this where a wire crosses over a wire without connecting? Or was it supposed to connect here? And it just brings that question into the fray. You can avoid that by never having four-way junctions. That way, if two wires crossing over each other in your schematic, they do not connect no matter what. And if there's three wires that are connected and one of the wires stops at that connection and there's no dot, you go, oh, well, clearly that's not just a spontaneous antenna. That is a three-way junction. So no four-way junctions, and everybody is happy. Oh, but bother, it'll get a little sloppy when I have like a voltage divider. Okay, that's fine. Like a couple cases where a four-way junction would be better. You make a judgment call, but my judgment call is always to not do a four-way junction. And the schematics are just much more readable, and if you are a fuck up like I am, you can fuck up and it won't mean disaster. What I'm trying to do is get both of these to flow over at the same time, because apparently this end is not having any of my crap. Look at that. It's like refusing to solder. This wire sucks, which is why I'm phasing it out. All right. I think that's attached. Ugh, I can't even see. I can't see anything that I'm doing right now. That very well may be a cold joint. Do I trust it? Or do I throw a lot of solder on top of it and hope that it comes out in the wash? That is a cold joint. Oh my God, it's like the coldest of cold joints. I'm going to do desoldering braid on this and just remove all of this slop that I've introduced. All right. A little bit more awareness, but there's so much flux in the area that I can't see anything. We move the light. Oh, geez, there we go. I didn't mean for this to be a hardcore soldering stream where people yell at me about my technique. We just had a bad voltage regulator. And now we have a good voltage regulator. It's a little bit more complicated. It's a module. Oh my God, I'm going to have a conniption fit about this fucking singular piece of wire. I'm going to have a total meltdown. I'll be stopping people in traffic, waving around. Take all my clothes off, jump up on the roof, you know, crazy person stuff. Put on a tinfoil hat. Why do you not like me? Why do you not? This wire is the worst. It's old wire, and it doesn't, it's like totally oxidized, I guess. I want the thicker wire here because this is carrying an amp. Oh my God, I'm just gonna live with whatever the hell this is. Whatever the hell I've just done, I'm not gonna. This is driving me crazy. I don't care anymore. Let's solder something that'll actually solder. I don't know why I use that freaking wire. Okay, so we are over here. And I've got in, ground, and out. So I need to hook this thing. V in, not shut down. V in ground, V out. Wrong way around. V in is here. So we have PG and shutdown hanging over the top, and these 3 pins with ground being the square pin. Oh, that's nice of them. They made the square pin ground. So this will not naturally sit like that. So what I'm going to do is just solder one of the pins and then rearrange this, and then I'll solder the other 2. We'll do one that's not the ground pin because that one's going to fight because it has all of this heat loading on it. And then remember, this is a temporary setup, so I didn't set this thing up to like be flush with the device or anything like that. It really is just standing out here in the wind. We just needed a voltage regulator that would power the rest of this thing, and because we had a couple regulators in here that had different pinouts, this one is kind of on this mountain of crazy, and it's got to kind of deal with all the previous residents. And then we'll plug this thing in, we'll power it up, and we'll see that nothing happens when I power it up, and then I'll cry. Or we'll find out that the problems of this board was not related to the regulator, and something else is going to explode. And it won't be my patience. So this one is the non-metered connection, and it should be up here like that. And then this can kind of just like get wedged, fool. Oh no, it can't get wedged like that. I actually need this to go this way. I would like it to exit the top, but I need to chew away like the top of the board to do that, because it sits flush against the rail when I do it this way. Nothing special here. I'm literally just using a bolt to wedge this thing. Means that it's not the best hookup. It's not the most even thing in the world. All it does is just hold my circuit board. It's actually fine at doing that. These larger sort of Chinese perforated prototyping boards. All right, so this goes to power. And if I flip it on and the needles go all the way up, it means that there's a short. That's the most likely scenario, is that there's a short circuit in something. Or if the needles go to super high milliamps levels, it'll mean that we need to go back in there with the soldering iron. I am moving all my tools off of the desk just in case the worst happens. But we looked at it. We could have double checked. If I was working alone, I would grab the multimeter and I would double check. But since we are working as part of a stream, I need to do the thing that's exciting, and I need to have chaos where it can be. So yeah, move this out here. Okay, ready? We're gonna turn this thing on and watch these to make sure they don't go super high, and we'll see if there's text on the screen. Nothing happened. Nothing happened. Nothing happened. Nothing happened. Nothing's happening. Nothing is happening. Nothing is happening. Okay, turn it back off. Well, it's not on the metered plug. I could put it on the metered plug and see what happens. Why did nothing happen? Did we not connect one of the voltages? Whoa. Whoa, 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 whoa. So that is the power supply module in the stand doing a little protectee on our circuit, and it's keeping this thing from heating up and exploding. So thank you module for doing that for us. So we need to investigate with the multimeter. I would have done it anyway, but we fail here in order to show off some of the features of things that you guys might not know about. Or you guys get to see how a professional deals with this kind of thing. Okay, so get this thing out again, and we'll get this thing off of here. And then I need to use a multimeter to check all of the stuff. Need to make sure V in goes to V in, ground goes to ground, out goes to out. Where's the multimeter? I gotta figure out what we're doing tomorrow. I don't want to just do this tomorrow. Oh, we might be doing the keyboard tomorrow, depending, because I'm supposed to get my circuits in, the flexi circuits. Or things will be so wrong with the flexi circuit that it won't matter. 1.9K. That should be on the ohms. That is on ohms. Ground over here. Ground in the middle pin on the ohms scale. This one doesn't get plus 12 volts. So plus 12 volts here. 0.7. Ground here. Oh, also very low. Dun dun dun. So ground and V in are connected to one another. So what did I do? We got to get back into this disgusting looking circuit and figure out where the short is. Doesn't really look like it's there, but it might be. We got this giant jump over here. So this one is plus 12. Oh, wait a minute. Which one is, wait, which one is, this one's ground. Ground to the middle pin is there. Well, that's output. So output shouldn't be connected here. I mean, it's pretty grody circuit stuff, but we're in a design that's been reworked a little bit much. 4K, and then from here to here. Yeah, I've got ohms. So why is that happening? What is connecting? Could it be, I don't think it's up here. That seems to avoid it pretty well. How about in here? That might have been it. I've been working with an excessive amount of solder on this, so it's possible that these little, yeah, like look at that. I think that might do it. Double check. Still 0.4 ohms. Where is your bridge, good sir? Show me to your bridge. Well, it's not going to be over here because we didn't touch anything over there. This is where we were kind of scooting our butt around. Was the act of me bridging this what did us in? Well, no, so it's wait a minute. This one is 12 volts. Check. This one is ground. Ground all the way up to here. Ground out and out. And this one is 3 volts, which isn't, 3 volts is fine. It's not shorted to anything. It's these two. This one and this one that are not only in close proximity throughout this board, they may be connected to one another somewhere. I have a feeling it's under here, under these two. If I scrape that enough, maybe I can separate them out again. Let's check again. Oh well. Oh well. We got an OL. It's sort of, oh damn it, 0.4. You can see that change. Ah. Am I misusing? This is ground. This is for some reason positive 12. Well, it's positive 12 because it's coming from over there, and then positive 12 also goes down this way. So when plus 12 comes to play, none of that's connecting to each other, which is good. Plus 12 comes out. Hold on. Plus 12 down here. Takes the coin. Comes up here. Connects here and here. Jumps over, well over, and goes to that pin, where it also connects to the wire, which is the second one here. Multiples in there. Where's there we go. Under and around, and it's got all kinds of like side stuff, but I don't see any other stuff going on there. I don't know. It looks fine. Why would it be shorted out? Is this thing broken? I don't think I've ever used it. We got the right values on this thing. If I unplug this, does it then not short out these two? In and ground. It's still in the ohms. So between L and M, I probably should have done ground a different way. Between L and M, it's shorting out. Okay, knife scrape. Use a real knife to scrape this. I feel like it's the only thing I can come up with. The only place I think that it can be shorted in this manner is under that bridge. It does look pretty clean under here, though. But I am running into something almost immediately. Oh, yeah, that's a big short. Wait a minute. Just can't see it because there's so much goddamn flux around. Oh, flux. Use flux. Look at what you've caused. All right, let me see here. Let's get a hot iron in there. You did this, not me. Oh yeah, look at that. There's all that solder. Just a big old solder bridge. I kind of want to spread this out a little bit. See if I can move one of the legs of it out, and maybe that'll solve it. Oh god, and then it like breaks the whole thing. Cool. Very cool. There we go. I may have to trim that. No, I don't think that'll be in the way. I just don't want plus 12 volts to go to my rails. My rails. Okay, that should solve the problem. So between the two pins here, we had a nice little ground loop going on. And we still do. Son of a bitch. Come on. What have I ever done to you? Huh? Like, I could run that to look a little better, but I'm just getting it functionally there. Seems like there's a little bit going on over here. Some days you just can't get rid of a bomb. Okay, let's see. That definitely does not look connected in any way whatsoever, right? You guys got my back on this one? Yet somehow, some way, I keep coming up with funky ass shit nearly every single day. All right, let's try that again. There's no way. There's no way, right? There's no way that these two will connect to each other. It just won't happen. It can't happen. I don't see any way that it could. None. It can't connect together. I've cleaned it up. It's completely 100% super clean, certified. Son of a bitch, it's still 0.3. What is going on? Is there some other kind of connection that I'm not aware of down there? Maybe I need to clean everything off. Clean it all up. Oh, that's so frustrating. Okay, it's like, at this point, did I connect something that shouldn't be connected because I wasn't thinking? It's like, that ground, I mean, that ground barely even connects right here. What if I disconnect it right there? It will probably say 0, it'll probably say inf or whatever when I remove this little piece of wire that was frustrating me earlier. Really getting on my nerves here, the little piece of wire. Okay, okay, you can leave. You can leave, thank you. Get on the hell out of here. Fully isolated, right? Fully isolated. God, some days you just can't even solder a voltage regulator in. Makes you really feel inept, especially when you got people watching you do it. A good number of people in here, too. Okay, now it's OL. So from here to here. Okay, it's 0.3. So something is still going on. It's not this stuff right here. I don't think that's doing it. This right here, this little clump, is our plus 12. It absolutely should not, in a million years, be connected over here to the stuff. So this is the highest one, all the way up here, is somehow connecting to ground. I don't think it manages to do it there. This is like barely connected. Certainly not the rest of my circuit. If I isolate this again and I rip up all this stuff, I'm just getting it all out of there because I'm getting real mad at it. I'm getting kind of mad at this thing and I don't want to be dealing with it anymore. So I'm going to rip up all this stuff and we're going to try again. Absolutely psycho. There's like maybe a tiny hair of a trace that's connecting it together. This is a lot of heat. I don't know why it's... Jeez. Is it still there? Okay, no, it's gone. And sometimes there's little bits of stuff that can ruin your day. See what that does. My pins are here, here, and here. So theoretically, it's now completely isolated once more. And so this one, even just to here, is gone. Yeah, it's OL. Here it's gone. But now this one to this one is 0.4 ohms. Ah, okay. So it's not the old, not the new stuff. Is somebody else, is some other component causing this to short? Well, the 12 volt to ground is new. That's a new thing. So that's questionable. That's frustrating. I mean, I can get rid of this little juke right here. Maybe that's what's doing it. The little sideways prancy bit. This is the other thing that we added in. This is ground, though. This is definitely ground. I don't know how it could possibly be connecting with plus 12. Unless this does some kind of a jump over here that I'm not aware of. This is just not my day. A lot of motion alerts at the front door today. I don't know what's going on out there. I think maybe packages getting delivered. I don't think I ordered a lot of stuff, but I do have those circuit boards coming today. I approved for the no signature DHL. They always make that such a hassle though. You gotta click and then do a thing and then do another thing and then, dude, just put it at my door already. So much flux. Oh, I think I'm running out of desolder braid. I think we have to use air. I'm just going to delete all the excess and then we'll see if there's still a short. Oops. And I really should probably clean this board. I need to get my ultrasonic cleaner up and running. I have it. I bought it. It's there. It sits there, making fun of me for having one. You gotta set it up with what? Like simple green? What do you use to clean off circuit boards? You put it in a bath of alcohol? Synthahol? Is this Star Trek? What am I doing? That looks a little sus right there. Make sure to put a hot iron in between them. I've seen circuits where people have scratched all the way down to the FR4 in between two connections, trying to chase down little tiny shorts that might ruin your day. All right, now to double check. Ugh, come on, meter. Don't fall onto my circuit. Giant magnet in the back for the magnet hanger makes it hang up on stuff. It makes it like grab stuff on my desk. I think I just insulted YouTube chat too much and they're not talking anymore. Everybody's still up. Bit rate's good. Viewership's pretty good. We're trying to get to the bottom of this so that we can actually test the mixer circuit. It's a voltage regulator swap that's gone pretty bad. It's gone pretty bad, if I'm honest. There's some really, you know, when I build circuits like this, they're always questionable, but this one especially so. Between V in and ground, there's a huge short that's now gone. It is now gone. Short. So somewhere in going up and around like that, I shorted positive vibes to negative vibes, and they weren't feeling it. $783K is okay. So what is happening here? This is positive 12 volts. This one is ground because of the way it is. Coming down, going over to here where it stops, and it needs to skip over and go to this one. In addition to that, this pin right here, better viewed on the top of the board, is actually ground to all of my other stuff. So from this one here, I can go to ground, let's say for instance, right here, and I get ohms. But if I go to VN and ground over here, I do not get ohms. I get 1.9K. But that's the low voltage characteristics of the devices are all kinds of they're all over the place. So ground to ground, ground to ground, ground to ground. Yep. Okay, so that one is ground. The one below it is plus 12. I go here, and then I go all the way to plus 12, which is on the smaller connector. Up here, I get 0.4 ohms. And on the connector itself, with the nub in the right spot, it is not the stripe. That's plus 12. Minus 12 is all the way down here. That's on the white wire. That goes all the way across. This is here. It makes a stop so that it can also supply the voltage regulator. This is 3 volts. This one is connected. This one has been the only reliable connection of all of them. The other two need to jump over one another in order to get to where they need to go. There we go. So I have a choice here of what I can do. I could bridge this using this tiny little wire. It'll probably be enough for an amp. And then get this right here, which is ground to ground. Now ground is all these center pins. So if I go here to here, yeah, I get 0.5. Okay, so we'll just do it that way then. Oh, you know what it was? That right there, that's why. Because that wire skipped over one and I didn't realize it. So my old philosophy on this thing would have been fine if I had made ground jump over, or or if I die of a cough right now. One sec. Ooh, probably inhaled a dog hair or something. Anyway, if I had jumped ground over, or if I had whatchamacallit? I know what I'll do. Oh no, I still have to jump over if I go down and over. Yeah. All right. We know now. Now we know. So V in can just go straight across because it already almost does. And I'll get a little bit of my wire wrap wire on this. A little sample of it. Don't need a huge amount. Wire cutters went back in the drawer. I see it now. It just means there's no way that I can get the other way. I have to cross over. God, there's a lot of wires that are kind of meeting up here. Hold on, let me make a nice right angle. Bend at the end of this wire, and then that'll help me kind of sneak it in. I don't like using this wire wrap wire to do one of those 3D bridges because they collapse so easily. Oh, come on, there's like pounds of solder in that location. My iron's still on. Okay, and then just do this. I probably need to put just a little bit of solder on that to kind of ensure its complete connection. It's such a small little. Now let's put all the adjectives in there. It's such a tiny little piece of wire that that doesn't get you any further. It's just emphasis of the adjective by repetition. Tiny little, small little. It's a little tiny. Little bit a little. It's all the same. Here, I think there's a little piece sticking up. There we go. Okay, so ugly, but it is connected. Ground has a tough time because ground, I don't know where there's ground anywhere nearby. If this is ground, then we're in luck. Is it ground? Is that just ground? One junction over there is ground. Are you freaking kidding me? So all this time I could have just come straight across here, except that nothing is connecting this ground to the actual plug. So if I go from here to here on row K, can't quite make it, but I can get close enough that I can just bridge these two, and then that'll be our ground connection. God, that's annoying. And then I can go straight across up here, and this will be connected to everybody as it's supposed to be. So we're going to do a big old wire wrap wire, and we're going to go from K to however far to the right we can get. But I need to find a piece of wire. There it is. This is my past self messing with my present self. Yeah, that'll... Oh, well, one more than that. One more than that would be nice. Just to be nice. None of my other bridges are going to be that short, but I need to make sure that I have the insulation on the top. That's the important part. Perhaps this one. That'll do. If I straighten it out a little bit. Oh, come on. Stuff. Sometimes things just don't cooperate. Right, and then that I can bend towards like that. And that's all we need. That's everything. Jeez. It was all so easy all this time, and I just didn't realize it. I should have thought more. I'm so sorry. Solder out here. This is very old school what I'm doing here. This is not like, and again, this is why I'm doing this like, I should be doing this in CAD because then I can just lay down traces, but it's much more comprehensive, and this is very sort of slapdash, if you will. Oh, what is going on there? Oh boy, I had a wire segment in there. All right, well, just get along. That's all I need you to do. Okay. It's like using a pair of hammers to program a computer. Sometimes it's not far off from that, to be honest. I guess that's essentially punch cards. That's how primitive punch cards are. You're using a little tiny hammer to program a computer. That doesn't look soldered to me. It doesn't look soldered. Yes, it is. Look it. It's got all the telltale signs of being a unsoldered connection. And then I need just a little piece of wire there. Ah, it was still hot. Need a little piece of wire for ground. This wire is old school and such. I guess it needs a lot of solder in order to get it to flow properly so that you can coat things so that it then cooperates with the rest of your operation. It's just old school like that. Why do you continue to humiliate me, wire? Okay, fine. It's fine. Everything's fine. I'm fine. I'm just getting mad at my tools like a good carpenter. You see that? You see that right there? A little cold joint. That's enough to send me over the edge. I gotta look at my timing, like when I stream, because I think I could have a lot more impact at different times of the day. My schedule's catered for me. It's like to keep me out of trouble. That just seemed to not really work all that well. It did not seem to work all that well. But reaching like a larger audience and like rubbing elbows with some other streamers that I know could happen if I streamed a little later. Of course, then I wouldn't ever see my dog during daylight hours anyway. Not during the winter. I don't like how this looks. I don't think there's anything I can do about it. as good as it gets, I guess. All right, so let's ohm it out and let's make sure that everything works. Jeez, this whole area is like on fire. Look at it on the thermals. Jeez. Okay, so we're just checking for shorts between these goobers over here. We don't have any weird three-dimensional jumps. And ground should be ground and power should be power, although it is technically in the configuration of an antenna. But we are dealing with DC and not daylight, so. Don't you dare say ohms after all that we just went through. All right, so there's that. There's that. There's this. Okay, so now we're ready for an actual test of this thing. Try to get this thing up and running. This is like the last stuff you do with a project. All this little troubleshooting stuff. And I guess it's good to show. I didn't mean for it to be this stream. This stream I meant to be actually characterizing the in and out behavior of the mixer circuit. What's up, Demi? How you been? I saw you with Sark. I saw you watching Sark. I was doing the same thing. I was guilty of the same thing. Okay, so this is very frustrating, all this little troubleshooting stuff, but this should actually work now. And then we'll have our outputs ready to go. I wish I had all of that concentration that other people seem to have in droves to program this thing, because this could have a whole comprehensive menu system, all kinds of functionality out of it. The mixer testing, or the module testing circuit module will, of course, have all of that, but it's going to be a slough. It's going to be a lot of work to get there. Watching you tinkering while sculpting. Hell yeah. That's what I do when I'm programming, is I'll put somebody on as doing other work. Boom has been the person who I've done lately to, while working, I'll put their stream on. Power right here. And I'm fully confident, so I'm plugging it in and then turning it on. Plug it in. 3, 2, 1, go. Yeah. So now we have enough current to power this thing. It's not on the metered circuit, so you don't see it down here. If I plug in with the other plug, you'll be able to see it using current. But this wasn't supposed to be so special. This is supposed to be just working. So now if I put the scope up on the screen and I take one of the outputs over here, plug in, we get some kind of a wave that we can't observe because there's so much amplitude. Sorry. Amplitude. So that's SAW. That one is the magic circuit that doesn't work unless I put my hand near it. Yeah, suddenly it's a sine wave. This one is another magical circuit that requires me to put my hand nearby. Reverse SAW. Why do you need me to put my hand near you? Why are you like this? I think there's some kind of filtering that my hand does. Look where my hand was. Letting the days go by. Square. Triangle. Other wave. That's just another sine wave. They're a little bit more reliable than they were. Yeah, that's pretty good. So this thing works again. So now the next step is to program it. Oh man, what a day. What a day. Let me open up Arduino because I'm too stupid to use anything else. Arduino, and then we're gonna have to look at the Paul Stoffrigan audio tools in order to figure out whether or not we can just say noise and it'll just be noise. I think it is one of the assignable waveforms that we have. A new version. Nah, I'm good with this one. Euclid 2, bounce. Moo 8. What is this? Tester module. Time bounce 5, blah, blah, blah. Pin up, pin left, up and down. Structure channels, which is frequency, amplitude, waveform. Button, bounce, bounce, bounce. This is all just set up for the hardware that I did here. Pin mode, pin up, input, pull up, bouncing. B up, attach, pin up. B left, attach, pin down. What is that? It's just bouncing intervals, press state, screen. And then we come down here to the loop, update the bouncers, update the display, and then update waveform. So update waveform. If this change, okay, so this is not complete. This is not what I was doing. Bounce with it, bounce with it. Open recent. Module tester, module tester module, module tester module, test module test. Hello world, bounce, bounce basic, bounce 2, module tester tester, or module tester tester tester. I think it's the one with 3. I probably could have named these a little bit more easy. There would be a whole paste of, yeah, this isn't it. All right, so we got to find it. File open. Desktop. I think this computer had trouble saving to the drive, so it might just be here on the desktop in a folder. Junk, K-bin, keyfab revision, clipper fixer, M303, module tester module. One of those. Module tester, module tester, module test. Is that the one we have open? We have tester open. This might be the one that I'm looking for. This just puts screen on the text and text on the screen, and it outputs waveforms. Nope, this isn't the right one. Which one do I have open already? Oh, this is the one that I just opened. Okay. Arduino wire, SPI, SD, and serial flash. Okay, this is the right one. Yeah. Waveform 2, waveform 6, I2S, and all that connection. Waveform begin, waveform sine, waveform sawtooth, square, triangle, sine. Let's replace this one with noise. Nope. Okay, so we need to look at the Stoffrigan waveform things. PNC 4.0. They don't have noise. That's annoying. Audio adapter boards for teensy blah blah blah. Not quite what I'm looking for. Audio library. Don't need a tutorial. Audio system design tool. We have waveforms and stuff in here. Do we have noise? No, because these are all physical things. I'll say play noise. Oh, and there's a whole synthesizer subset in here. If you want to use just the chip and build your own topography for a synthesizer, you can do it in these tools, and you can program it to a physical device that you can then connect knobs to. You can connect knobs to it. You can put an output amplifier. You can make a very simple synthesizer that does the exact things you want it to do. And that's actually something that we should probably do one day. Take these tools and just build out of a TNC4 a synthesizer. Now, we like modular synthesizer stuff, so you know, it's not quite the same, but you can still just sit down and have just like one of these things. Get a hand drill, punch a bunch of holes in this thing, right? Give it an output and turn it into a synthesizer with your own topography. I don't know enough about synthesizer topography to really know what I'm doing there, though. Yeah. Hell yeah, brother. All kinds of good stuff. And they even have, oh, here's noise. Create white noise. Bam. And we would want that to go to, instead of the waveform, we'd have that go to the thing. So now what I'm going to do is export this. Give it a week and you'll know everything. Audio output. Waveform. Where's noise? Do I need to dedicate the waveform? It's weird that the waveform can't have noise. Sine, sawtooth, reverse, square, triangle, variable, triangle, arbitrary. Arbitrary is one that I would like to put in, but let's put in noise into that last channel. Then I can just take this code block, put it in, get rid of the waveform 6. And then this goes in here. Oops, we didn't need all that. Okay, so there's this tools board, TNC4. We're all set on that front. I need to find my programming cable. Where have you gone? Programming wire. What is this one? Oh, that's Stream Deck. That's Stream Deck. Leave that one alone. I think there's one that's dangling around here somewhere. No, it's not. Okay, so I can grab one from the drawer. This drawer over to my side, and I can plug it in. And then we can program the board. Where have you gone, programming wire? It's around here somewhere. Yeah, I mean, I could learn all of that synth topography. What I'm doing is I'm getting through all the building of stuff, and then I can sit down with like a fully functional modular setup and learn it from there. And it's not an ideal way to do things, and you know what? It's more fun to not do things the ideal way. I don't want to sit down with a book. How to use a synthesizer. No. I want to just plug stuff in and make mistakes. Mistake number 1, where did that wire go that I used to program microcontrollers? This is one of those things that I need like a permanent setup for. I need to make a better setup out of this whole thing. So all the wires that I like to use sitting in the right spots. What are you? Oh, you're an audio cable. You're not even the right kind of cable. I had the programming cable out and about at one point, and I probably didn't put it back properly. So now it's down to me sifting through. Actually, I think there's one over here that I can use. I was recharging something. Yeah, this is a USB-C. Not useful. USB micro. Okay, yeah, that's the right one. I was like, if that one is USB-C, everything in here should be USB-C. Everything, even the USB-A connectors. But we don't live in an ideal world. Come on. I want to, at least by the end of the day today, have noise going in and noise coming out. Because then we can look at the FFT on the scope. The fast Fourier transform, what it does is it moves you over into frequency space. And frequency space is something that we use in the mathematics of engineering quite a bit. Where instead of, how do I explain it? You're talking about individual frequencies that are mixed together. It kind of picks them out and puts them into a different way to see things. And I haven't worked in frequency space for a long time. I used to live there. So I wouldn't know, I don't think I would know quite how to advise. I don't really know how to describe. Is that really outputting a waveform? That's unique. I think it's charging a capacitor, and then every now and then it works to output a waveform. Maybe to program this, we need to remove this thing. It's hard to get out of the sockets like this. I don't want to bend any pins. Need to pry it from 2 ends. And one of the ends has a glass screen, so that's fun. Fun, fun, fun. I mean, I could plug it in while everybody's powered up. I think it would be okay. It might not be able to reset itself. Maybe the pick will do this. Which is where? Where's the pick? I just had it. Son of a bitch. Oh, here it is. Snuck all the way to the side of the soldering iron. 1 sec. I'll get it. I'll get it. What the hell? I've I've never had this happen before. All right, I guess I'll just program it with it plugged in. Hopefully it'll still be able to reset itself. Just like that. And then check to see that the board says that it's connected. No programmers. 4.0 serial COM4. Oh, port is selected as COM4. Okay, so that's all connected just fine. So I can just hit upload on the code. I have to wait a little bit for it to do its thing up here. So this is the reason you do hello world is so that you know that your pathway from your console with your code in it or for whatever you're using to program, the pathway from there to your device is good. I've spent lots and lots of time trying to figure out what all the problems are, only to have a hello world program kind of throw me on my ass and tell me that things are connecting in properly or, you know, USB cable's weird. We've had a time where we troubleshot a circuit for quite a lot of time, only to discover that it was one of those USB power only cables. You gotta watch out for those. Those are insidious. The ones that only run power and don't have data lines. What's happening right now is this is compiling a lot of teensy stuff just because I haven't run the programmer in a little while. It's gonna do a lot of compiling. The follow-up programming from this will be lightning fast. It'll go in just instantly because it knows it doesn't need to compile all these different components. It only needs some stuff to be compiled again. But since I haven't done it in a while, now it's really taking its time. It's doing a lot of different little things. So we wait. Unfortunately, as microcontroller programmers, we don't quite get the same kind of compiling delay that computer programmers get. We can barely get out to the coffee room before the microcontroller has been completely programmed. So now, on this channel, we should have nothing. Absolutely nothing. Okay, that one's still triangle. This was supposed to be noise. We'll just check the other channels just to be sure. This one I have to do this. I don't know, is it like a distance from the microcontroller thing? Might be. Okay, everybody else, you know, except for the fact that I have to punch my thumb on that one, works. The noise output did not seem to function properly. Do we need to give it some kind of an element of amplitude? Or are there other parameters? Out 0, white noise, creates white noise. Set output level from 0 to 1. Functions, amplitude. Okay, so we do need that. We didn't do that. So let's see. Waveform begin at amplitude 1. Here it is. Noise 1. Amplitude. You got that tude. That amplitude 1. And then plug in and upload that. The screen looks really good. I wish it looked better on camera. And you know, screens are a lot of work. There's a lot of like shortcut programs that try to help you with screens. They're always just a lot of work. They're always very annoying. And I haven't spent the time to actually make it do anything. But it's this little yellow OLED. It looks very nice. I think the yellows look better than the whites. I wish there was an orange. I wish I were an orange. It should be much faster. It is much faster. Still doing a lot, though. And then the teensy window pops up. No, I guess it popped under. Okay, and then out here we get full volume noise. Cool. All right. So the adapters that I don't have are splitters. How am I going to do that? Well, I guess for now we could just show the thing working as normal. Now that Pololu regulator, how's that doing? It's not even getting warm. Perfect. That's the problem. The problem with the circuit that I made is that it gets extremely hot. I don't know why. It's not a totally excessive amount of heat, but it's way more than I would like to have in like a mixer circuit. It's kind of inexcusable having the amount of noise that we have. But if we pump that noise into one of the channels of the mixer, and I power up the mixer, make sure that stripe is on the right pin, stripe goes down, this, stripe goes down, and then I can plug my stereo output here. Of course, it's not going to quite work because it's. Oh wait, no, this is. Hold on. There we go. Stereo here. Nope. Stereo here. Would you just give me the cable? Please, just give me the cable. Everything. It's like a knot of cables everywhere in here. So we put noise into one of our channels here. We get nothing. Good day to you, sir. Turn the volume up. Turn the volume up. There's our noise. It should be equally shared on both of the channels. Oh, but we turned the amplitude of the other channel down. There we go. There's our noise. Turn it all the way down. Turn it all the way up. What kind of delay is there in the noise? This ought to be weird. If I advance this way up, and then I stop, because this is wacky, waving, wibbling, arm flailing tube. Because we're designing this in analog, there's actually very, very little delay between the two signals. So if I stop this, if I hit stop, whoop, let's try that again. Single trigger, there we go. Single trigger is nice and clean. Then I can move one channel over the other, move them both to the center. There's a bit of a high frequency component in all this, but it seems to have been there from the start. So this must be my LED lights causing interference. But if we move off of that and look at the big waveforms, there's like no delay between them. That's pretty impressive, actually. That's really impressive. I didn't expect there to be like no delay. And this is just noise running through the whole thing. It seems like our in and out is just so well coordinated. Just that very tiny element there. And we're talking about, what is that? Absolutely tiny increments of time. There you go. There's time is equal to 0. Woof. How close can we get? Trigger's getting in the way. What is that? Why is it blue? What's going on with that? Strange. Let's run that. You can just see how fast, this is how fast it's interpreting it. So, if I zoom out and do an FFT, I don't know if we're going to see a lot of difference here. Math 1, source, channel 1. Operator, A minus B, no. Operator needs to be FFT. And I guess we're okay on that one. Operation is on. Auto set. Well, there's no real data there, huh? Zoom out until we have 12 hertz. 12.7 hertz. So how do I... Oh boy, I need to learn how to use this thing. Because like the frequency makeup of this, I think we're way zoomed in. Can I pinch? Can I pinch it? I don't think that did anything. Negative 123 dB. What am I looking at? Okay, well, it is not exactly a frequency sweep, so I don't know. Maybe I need to learn a little bit more. I need to read up on the scope and how to use the FFT function, because I could poke around buttons a little bit and try to figure it out a bit more. But I guess we've been streaming for a little bit for my reintroduction back into society. We're at about 3 hours and 30 minutes. I don't know if that's an appropriate amount of stream time, but at the same time, anything that I can get into, I need to kind of research a little bit more. So maybe we split for a little bit. It's going to be cold tomorrow. It's going to be a cold Friday. And so we'll be able to work on something that's maybe not this stuff. I don't know. We'll see. It depends on what I can get into. The mixer, I think I'm ready to just give it to Julian, because it seems for the most part, it just works, right? It goes up to like 1.5 almost, 1.6 volts. It is able to reproduce in the same phase the wave that comes in going out. Now, I probably need to like get a sample of Never Gonna Give You Up, put it on an SD card and put it into the Teensy. Oh, this one doesn't have an SD card. The other one does. Figure out how to replay that out of the audio engine so that I can actually listen to it and say, oh, that sounds good. There's so many variables in that, though. Maybe I could hook it up to some other part of my setup, but I need to run audio through it, and I think Julian's the best bet for that. He'll be able to listen to it on the other end and go, yeah, this is fine. Or, I don't know, maybe he'll find problems with it through and through. Usually this is the part of, I'm stopping a little too early, so there's not a lot of people around. This is the afternoon people who are leading in. People say your numbers are better for going earlier, but I don't know. Robert's playing Kingdom Come because he's just completely addicted to it. Other than that, the bottom of the list, paleontologizing is doing stuff. I don't know if we're ready to raid into paleontologizing. And nobody else is online. Okay, so I'm just gonna stop here, but I mean, we had a great time today. I mean, this is like my first stream for a while. Lunatic Lives rated. We had, let's see, 6 days, 3 hours. We had Veet Nukem and Syphilid 8 sub. Hey, good times. Thank you guys for joining me. This is a little bit frustrating because it took us a bit to get that voltage regulator in there. Now that we've got a good one, we have enough power for everybody else. One of those packages was probably the LM1117s that I ordered, the ones that can handle a little bit above 800 millivolts without breaking a sweat. And maybe then that'll solve this board's issues. Although I don't think I'm going to resolder that again, because those are very frustrating. This thing seems to work now. I'm going to ride it until I build the real one, which will use that 1117. Yeah, and until then, I'll be in the Discord, so you guys can find me in there. Let me do the exit command. As soon as I mention it, people leave. Oh God. Discord Nitro, thanks. Discord for all the pop-ups, appreciate those. So into admin and into highlight of the thing, edit the com to say tomorrow, which is the 9th, we will get together and we'll do some cool stuff. I had some weird idea for a stream that I don't know if I'm going to do anymore, but maybe we can start building the bother emote kicker or whatever. We can get that into CAD or something. That'll be a fun one to do. Until then, yeah, you guys be good. I'll catch you later. And go do. Is that hopeful enough? I guess so. I updated the command, but then I didn't use it. This is how discombobulated I am today. Here, bada bing. There you go. All right, you guys know where to go, and tomorrow we'll try to work on something a little better than this. I think the mixer's ready for Julian, so we can move on to other stuff until he gives it the thumbs up or the thumbs down. I hope it's the thumbs up because I got to redesign the whole goddamn thing because I got the knobs backwards.